training organizer.
Okay.
Your trainer, Mr. Tiven, is on the way.
So I sit over here?
Yeah, actually. You bring your own laptop.
Yeah, I bring my own
Then
laptop.
later can install. So you have the software?
I don't have the software.
Then later he will install it for you.
Okay,
The software.
Yeah.
Then after that you can use your laptop.
Okay,
Yeah, for now we use this one. And the manual is right over here. Soft copy should be inside. Is it on?
Yeah.
Just exit one. Okay, I will give you a quick introduction before he comes and starts with me.
Okay.
Okay, my name is Warren. As I said, I'm the manager, training organizer. We have two company names, AS Automation Services and AS Automation Systems Training Centre PLC. So my boss, Mr. Sundaresan, is now retired because he used to be the trainer here.
Okay.
He's my father actually.
Oh, okay.
Yeah, so he's now retired due to his health condition, due to his stroke. But his background, he was an ex-army technician. He served under the army under DUDM for I think 25 plus years. Like he completed his service. He's from Kedah. He's from Kedah. Then he got his scholarship in Royal Australian Air Force. He did his instrumentation engineering there. After he finished his course, then that time it was in the 90s. So he came down here, settled down here, looked for a job in Singapore. At that time, Singapore was booming. So he looked for a job in Singapore, and then he did his studies in diploma in industrial automation in Nanyang Poly. And from there, he became passionate with PLC. So the first PLC he touched was the S5 PLC. Later Tiven will show it to you. That one is a DOS-based one, not Windows-based. Where you still got some company running with the PLC. They say still running now, even as it is now. Got problem in, that's it.
Obsolete already.
Obsolete ready, cannot get parts or anything. so we do convincing, we try to convince them, swap to S7-300 maybe. Depends on the machine spec. So, and since then he became passionate with PLC, and the first PLC he touched was S5, and after that he slowly moved to Allen Bradley, the RS 500, and that one is the control logic. Both also using different software. Then after that, he slowly moved to Mitsubishi, Omron. Then the less demanding one like Kiels, GE Fanuc, Schneider PLCs. But Siemens is always demanding. Siemens is always high in demand. Okay, so after that, I think he completed his his base experience itself is I think he completed around 5 years of experience, and then he also worked in overseas last time also, and he did his another certification. He took his another certification competency under Siemens in Germany as well. After he completed that, then he collaborated with a German partner. His name is Andreas, and opened up a company called AS Automation Services in Singapore. We have one branch in Singapore actually. But that branch now we split up really, but that one is mostly focused on project and consultation. So in 2012, when my boss opened up this company, we also first focused on project and troubleshooting, consultation all around here, 100 km radius only. Project we do it worldwide. And then in 2014, when I joined in, because I was working in a different company, I joined in, we registered ourselves as a training provider under HRDCorp. And then since then until now, we have trained more than 4,000 plus participants. Already hitting 4K already. Not only Malaysia. I don't know how foreigners find us also. We used to get foreigners, we did get foreign participants from Libya, Turkey, Mongolia, China twice. China because I had a contact there. Philippines, Indonesia used to be our first customer. We kickstart because of them from Batam. We kickstart because of them, and then all the way last year we had for the first time we had Muhammad Saleh. A Scottish person, a Scottish guy. He was doing some project in Singapore, so he came down to join us as well. For Siemens S7-200 using the airport. The new one. So yeah, and since then, then Tiven is on the way right now. He joined us in 2015. He joined us in 2015. His background is mechanical. He's from Mukama Poly. He also was trying to look for a job in Singapore, couldn't find it, so he joined us instead. And he did his studies at the same time in UTM. did his mechanical degree in UTM as well.
Mm.
And then he worked for us part-time. Now he worked for us full-time already lah.
I see.
He took over, basically he took over my boss place.
Oh.
Now he become the senior trainer.
Understand.
So time to time we also used to do services around here. If where are you from?
Actually I'm from Kedah also.
Oh, Kedah.
Kedah,
Kedah kan?
Kulim.
Oh, Kulim area.
Yeah,
Oh,
yeah,
okay.
yeah.
Most of my cousins are from there.
Oh.
My father is from boss is from SP.
SP, huh? My
Yeah.
wife is from SP.
SP also. Yeah.
Yeah.
Because he served under this one, Simatic, UDM, which one? Near to Bunga Raya.
Oh, okay,
Near
okay.
to Jalan Bunga Raya area. Yeah. So yeah.
But now you guys stay over
And now we settle here already lah.
I see.
I also not from here. I'm from Perak.
Oh, okay.
He also from Perak. You know.
Oh.
So yeah. So you came all the way from here, from there.
No. Because actually I work at Singapore.
Oh, you work in Singapore also. Okay.
Yeah.
Where?
Work at what's that? MRS.
MRS.
MRS is doing a mechanical job.
Mechanical job.
Moving CNC machines.
Boss was working under last time was sharing cloud. Now become MSD really.
Oh, okay.
Yeah. He was an automation consultant. There.
Okay.
Yeah, but I can't remember really exactly which time.
Oh, I see.
It's a long time already. I entered Singapore.
I see.
Yeah, after I retired already, I had no reason to enter Singapore. So yeah. I also was working in Singapore under Simatic, Singapore for 2 years.
Okay.
For 2 years, then I got bored already. I coming back.
Understand.
So yeah. Okay, so sweets, water bottle, all right over here. If you need to go to your, go to washroom, straight to your right. And black coffee, tea, all 3-in-1 coffee packet. I prepare already. Glass, prepared. Hot water also prepared. Feel like home. One batch training me.
Okay.
I tried to do marketing. No one wanted. Simatic manager all wanted. Alan Bradley lah, TI photos. Okay lah, never mind.
Okay.
Normally, if one participant choose that one particular date already, I'll just ask them permission first. If I do marketing or not, or you want one-to-one training.
Oh, okay.
Most of the time they say, do lah. The more the participant, the better. They can do they can do the project together.
Yeah.
One brain not enough, no. Doing this programming, you need at least 2 brain over
Yes.
there.
True.
So, Simatic manager not much demand. That's the thing. Everyone prefer, everyone wanted to learn S7-200 or S7-500, which we have one unit. Just only this year only we bought one unit, the 1500 one. They want to program using that with TIA photo.
Oh,
Even Simatic, even S7-300 also can use TIA photo like program.
I see.
But some people, because their machine still supports Simatic manager,
Yes.
they want to learn Simatic manager.
Yes. Same like me because most of my machine is using S7-300. So that's why I want to learn the S7-300.
What type of machine are running?
Pardon?
What type of machine?
So it's like something like boring machine. Like oil and gas, like there's one part you need to bore. Only that type of machine. But the thing is, it's using S7-300, and then we use all outsiders to troubleshoot. So that's why I wanted to learn.
Double, triple charge.
One time.
We also can come to Singapore and troubleshoot for you. We won't charge that much actually.
Okay.
Because if they triple charge, we just double charge. That's all. Because I think normally per day we charge around 1,500 or 1,500, 1,600. But depends on the distance.
Understand.
Depends on the distance. 1,500 to 1,600 per day. For the troubleshoot. So have you touched any PLCs before, or this is the first time you are basically basic?
First time for this
Have you touched other PLCs?
because CNC mostly use Fana and
Oh, Fano. G Fano PLC. You can be that also.
that's why more to
G-Phone mostly, I think last year we did conduct only twice.
I see.
Not many. Yeah, because G-Phone mostly all from the participants and requesting companies are from mostly from the oil pump factories. And also mostly also from oil and gas as well.
Yeah.
Siemens, this is the first time I'm hearing that oil and gas using oil and gas sector using S7-300.
S700 until now, there's three of my customers all using S700. Yeah.
Because most of the time, those participants from that sector will request for Allen
I see.
Allen S7200.
But if let's say one of the parts, or let's say the IO card spoil, right? Because I encounter one of the inbuilt relay as spoil. So I have to change the input output.
Don't have backup relay.
Yeah, that's why I have to.
That's why I need to put additional backup relay.
Yes, correct.
If overload, at least that relay will protect its PLC.
So we can't find any spare part for this anymore. S700. Because some
maybe later you share to TVL for the spare part. What spare part you're looking for? We have plenty of S7-300 cards with us, but mostly all not without the box lah. Because not sealed already lah. Consider refurbished.
Yes.
Most of the time we only use for tuning only. We never use for any heavy duty or what.
Because some of my customers, the iPad spoil, so I don't know where to find. So at least
you find from us also. We
know that it's set already. Then okay.
Yeah. So company profile is right over there. All our introduction is there.
Okay. Can I see?
Yeah. Please. That one is for you.
Okay.
So not only we conduct training. Training is been our main source lah.
Yeah.
We also involved in troubleshooting. We also can do project when we are available lah. So we always prioritize training most of the time. So based on our schedule.
Okay.
So we also built a training kit as well. We also build custom training kit for industries.
Okay.
If industry requires can you build for us a training kit, we can do.
Okay.
We can build a training kit using the toolkit box.
Yeah.
With the PLC HMI and everything. So we can practice in future time.
Yes, understand.
So currently project, we just only yesterday commissioned one project in UTM.
Okay.
For a UTM project, they also requested because they've been sponsored to build a CCUS chamber. This chamber, how to say, because they are the one doing the project. We are only focusing on the control panel part and the programming.
Yeah.
So it's like the they're trying to collect CO2 and trying to harden the concrete brick. Something like that. I still can't able to understand the clear picture what they are trying to do. So they have this concrete brick, they put inside the chamber, they release the methane and the CO2 gas over there, and they try to harden the brick.
Okay.
Harden the concrete brick. So they're doing that research actually. So the main goal is they don't want the CO2 to release in the air and go into waste. They at least want to use the CO2 for something else.
I see.
Something like that. So they bought the chamber and they asked us a favor, can you join in and do something about this? I said, okay, we'll do that. Even though there are 7,200 per panel, and we communicate, we bought the sensors and all. We asked another of our partner to come and join in as well. They do all the welding part. And once done already, we tested, okay, all good now. Still need to buy the stand for the control panel and everything. And once finished, the only sponsor under Petronas. So project time to time we do maybe every year, one or twice we involved in project. More involved all the time. So if you're working under Malaysian company, can come under HRDCorp.
Right.
Singapore cannot.
Singapore, sorry.
That's good. Oh yeah, coming up. Okay, okay. So when come to training, as you can see, we can order training for most of the PLC brands.
Yeah. So yeah.
So we do provide for 3 days and 5 days. Now you take 5 days ready. If you want to learn another PLC over 3 days, is enough for you. Okay. Because day 1, day 2 will be the basic, fundamental of ladder logic, wiring and everything. Day 2.5 only you will start touching the programming and part.
Okay.
But I think basically Kivion will start jumping to the programming straight one based on your knowledge. So once you gain the once you understand the fundamental already, the other PLCs will be easy for you.
So about the payment, do you receive? Do you accept credit card?
Credit card? Credit card means swipe, right? Yeah, we don't have the swipe machine.
Oh, okay.
Yeah, we can credit transfer. Yeah.
Or transfer online.
Transfer online. I have the QR code with me also if you want.
Okay.
Let me come and start the training first, then later you can settle.
Okay, sure.
Being stuck in the gym today Monday.
So you guys also build a panel for customers?
Yeah, we can build panel. It depends on how big the project is. If it's really a complex one, then I will start calling in other of my partners to come and join in as well. But it's a simple, small panel this size, all we can do by ourselves. Depends on how much quantity and everything that we check everything like that based on the BQ.
Okay.
Morning. Mr. Good. How are you my production? So
Yeah.
Should we start your training?
Yeah.
Mr. Hadi, right?
Yeah.
Yeah. So you just know the car stuck in the tool.
As usual.
Okay.
Yeah.
Yeah. So do you work with PLC before?
I work with Fanak. Only Fanak CNC.
CNC.
CNC, yeah.
Oh.
Because actually I'm in CNC industry.
Oh, in the
Yeah.
industry.
Yeah. But I never touched S7-300 before.
Oh.
Just that always we call supplier to help us. But the thing is the cost is very high, that's why I wanted to.
Yeah. Yeah, the supplier
Yeah.
come and check the
That's
car.
why even change IO only cost very hard.
Oh, change the IO.
The IO input only.
Oh.
Yeah, because that time what I troubleshoot is I can't find because there's S7-300 is 100 volt and 24 volt.
Okay.
So the 100 volt is not coming out, but there's a how to say there's an output that I can see in the HMI.
Okay.
Yeah. So
But there is a, oh, okay. The
yeah,
output, okay.
the output, but there's no
The voltage there.
Voltage there.
Okay.
So that's why I have to ask a supplier to come and change the IO. That supplier charged me very, very high.
Oh. Normal.
Yeah.
PLC is expensive.
Yes, yes, expensive, yes.
Because of the number one is actually the main is the software.
The software.
The software
okay.
is expensive.
I see, I see.
Yeah, that's why
It's
they
because of the license.
Yeah, that's why they charge so expensive nowadays.
Oh, okay, okay.
Okay, never mind, no problem. Okay, so you create a folder in the desktop.
Okay.
Okay, hold on. So you're working in Singapore, is it?
Yeah, I'm working in Singapore.
What company?
MRS machine.
MRS.
MRS machine tools.
So you're supplying machines, is it?
Supplying machines and also repairing machines. Or CNC, yeah.
Okay. Mostly CNC machines like
CNC machine, yes.
using Fanuc.
Using Fanuc, yes.
Fanuc is Japanese one, right?
Fanuc Japanese.
So the soft copy manual is this one, this here. They want copy, you can copy that.
Alright.
Okay. You start from the basic lah, okay? Now, but you are familiar with wiring, hardware.
Wiring, okay. Yeah.
Right. So this training will be Siemens Simatic Manager. Okay. Alright. So this is example lah. Yeah. Okay. Next. Just enter. Okay. So we know that PLC is okay widely used for any industry also can. Okay. Even the CNC, your CNC machine also can change to PLC also.
Yes.
Okay. Right. So very simple lah. PLC is very simple. It's just a computer where you can program the computer. It's an industrial computer, so we have input, output, you can program. So when it's come with the empty program. So we can program how we want to control our system. At the same time, why they use PLC? Because number one, it's an industrial standard, because it's not durable, okay, all that. Then number two is it can got errors, it can extend the IOs, all that. Because have you heard about Arduino? Arduino is like they call it a microcontroller.
Okay.
You
mean like the chip?
That one also it's similar concept like a PLC. That also input, output, can program everything. Okay. But that one is not for industry. That one is to if you're doing like a school project, ministry project. Another one is called Raspberry Pi.
Okay.
They also same. So there's a few controllers. But PLC, of course, PLC from last time we had, right? Okay, I think PLC already is there during the computer time, because when they developed computer, they created PLC also. Yes, alright. So Siemens also one of the old PLC. Okay, old brand. Okay, next. Okay. So these are the models, Siemens models. Okay, so initially they call Simatic controller.
Okay.
Simatic, that one is not like considered as a PLC. Okay. Simatic controller. That one is it's not a programmable.
No.
It's like a controller, but I think late 50s lah. Okay. Then they have S3, Siemens S3. So that one is not also as a programmable. Okay. Then I think late 70s, mid 70s lah. They come up with a hardware called S5 CPU. So this is the S5 CPU. The old one. Yes. From the 70s PLC. More than 30 years. Yeah. Still company using.
Still company using.
Yes.
Wow. But if let's say now no replacement anymore for this, right?
Yes, of course. So all no replacement. That's why this one all I keep as a spare.
Okay.
Just refurbish, checking all working on, and just keep as a spare. So
See.
it's not all obsolete really. Okay. So that one is using step 5 software.
Step 5.
Yes. Okay. That is considered in PLC in PLC that is considered the first generation But under Simatic controller, this is the third generation. The first two controller is just like a controller, just connect like the small timer. You can connect all the input, then adjust the timer, something like that. Okay. Then they come up with the S7. Okay. S7 they have for S7-300. 200 is this one. This one is 200.
Yes.
200. So this is 200. Okay, this is 200. So this one is using microwave software.
Microwave.
Yes,
Okay.
microwave software.
I see.
Then at the same generation is come the 300.
Okay.
The 300 and the 400, which is 400,
Okay.
and 8200.
Okay.
So this 4 is the same generation but this one is using different software. They call microwave.
Microwave.
Why? Because this one is a compact. For smaller machines, you can use this. Then if you have a bigger machines, more number of I/O, then you can go for the 300, 400 or 8200. 8200 is considered like a remote I/O. For that they use this. Okay. For big system, have you heard about redundancy? Main and redundant.
Okay.
It means you will have one main PLC.
Okay.
This one CPU 414. Okay. Then you will have the exact same another one.
Oh,
the
okay,
CPU,
okay. So
like
the master instead.
yes.
Oh, okay.
So then both this one we connect to one set of I/O, right? This one down, that one take over.
Oh,
That one called main. Same concept as master
Oh.
and slave lah.
Okay.
The main redundancy only can do in this model.
Oh, only this one.
Yes, only 400 can, 300 cannot do.
Okay.
So that's why some company when they need redundancy, they will use this.
Okay.
But the remote I/O, then you can use this.
Oh, okay.
They use this or the 300 models can use.
Okay.
Okay. And these three models is using Simatic Manager software.
Oh, okay.
That's what we're going to learn lah.
Okay.
Simatic Manager software.
Right.
And the latest one from Siemens is the 1200
Okay.
and 1500. Okay, this is 1200.
Okay.
This is 1200 and 1500. This is the 1500.
Oh, okay. With the screen already.
Yes, the screen already. This one got Ethernet port.
Oh. Oh,
Okay.
it's not the old one don't have.
The 1200.
Oh.
Yeah. Now all Ethernet only.
Okay.
Now don't have the what that is the serial port.
Oh, okay.
So now latest software called TIA portal. Totally integrated automation. Okay. So this TIA portal, when they release this TIA portal, they release new two hardware, 1002 and 1005. Okay. At the same time, this TIA portal can program the 300, 1800, 400.
Okay.
Program also.
Okay.
Why? Because what happens TIA portal is how the TIA portal work. Okay. For PLC, Simatic Manager. For HMI, they call it MCC.
Okay.
They combine together, make it TIA portal.
Oh, okay.
So that TIA portal inside that software, you can program for PLC, you can program the HMI, you can program SCADA, everything all together in one software. That Simatic Manager is only for PLC hardware, everything. HMI we use MCC flexible. So all together. That's why TIA portal can program also.
Okay.
But the thing is, so let's say the programmer use TI portal to program your 300.
Yes.
Let's say you want to use Simatic Manager, want to backup, cannot.
Oh, cannot.
Backup cannot. Because the programmer use TI portal.
I see.
So you must use TI portal.
Use that here.
Yes.
Okay.
The same thing also. Let's say the programmer use Simatic Manager. You cannot use TI portal to backup.
Oh, okay.
So,
Understand.
but when we, because let's say we don't know, this one using Simatic Manager or TI portal, nobody. You just try to backup. If can, it can. If cannot, it will show you the message.
Oh, okay. Understand.
Okay.
Yeah, I heard from my supplier. He said when we back up the S7-300, there's no comments.
Yeah, of course. No comments.
No comments. Oh. Okay.
No comments. TI portal, yes, can.
Oh, only DIA portal can back
Inside
up.
TI portal can.
Okay.
Okay, I will tell you what is the difference.
Alright.
Okay? Because Simatic Manager, they use symbol. They call symbol.
Okay.
So when you download to the PLC, you only download the program. You are not downloading the symbol.
Okay.
So it's not inside the PLC. So when
Okay.
you back up, you cannot get the symbols.
TI
portal, they call tag.
Okay.
Tagging. Yes. So when you download the PLC, you download the tagging also.
Oh.
That's why when you back up, you have the name.
Okay.
That is the difference.
I see.
Okay. Alright. Okay. Next. So the regarding the hardware software, understand? Okay. Any hardware same Any hardware. Okay. Let's say you working with a new hardware. You suddenly see a model.
Yes.
You don't know what is the any brand. For example, Omron. For example, you see Omron. Then suddenly you see Omron part number, but you don't know what software they are using.
Yes.
It's very easy. Just type in the part number in the Google. Then just type in programming.
Okay.
Sure, they have some videos. Then when you open the videos, you can see what software they are using. Okay. So If you learn one PLC, then if you want to learn other PLCs, it's very easy.
I see. Alright.
Okay? Okay. Now, so this one you don't, I think you don't take, because PLC consists of input and output. Okay? Very simple. That is, we have a digital and also analog inputs, digital and also analog outputs. Okay? Then the most important part is the software and the cable. If you have software but don't have cable, cannot learn.
Yes.
If you have cable, if you don't have software, cannot learn.
Yes.
Okay? But the newer PLC like the 1200 and 1500,
Yeah.
you can use Ethernet, no problem.
Okay.
But this one, these cables are, you need to use the special cable.
This one.
Yes, the adapter.
Okay.
Okay? Alright, next. Before we go into the programming or PLC, we need to understand what is the numbering system, computer numbering. Okay. So your background is what? Electrical?
Actually, more on the mechanical side.
Oh, mechanical. Okay. No, I also my background also mechanical. So
Okay.
I come here only I learn all these PLC. Okay. Right. Okay. So actually all these we learned before lah, right? In university, in college time,
Yes.
school time, all these were just different. Okay,
Right.
because PLC they are using all these only. Okay. Next. Okay. Decimal. Decimal is the number we use every day. Okay. 0 to 9, then so on lah. 10 to 19, 20 to 29, and so on. Okay. Then we have hexadecimal. Okay. So in PLC normally we use decimal only lah because easy to understand.
Yes.
When you write program, all that troubleshooting and so on. Hexadecimal, some place we use hexadecimal.
Okay.
Okay, some place. Okay, it's depend on the program lah. And also when we do programming for motors, for example, if let's say we have a Siemens, this one Siemens driver.
Okay.
Maybe the last day we might use this one
Alright.
to control. Okay.
Okay.
So when you use Siemens drive to do programming in your PLC and control the driver. Okay. Of course, the drive will have some value, some command you need to send.
Okay.
Correct. So when you refer to the manual will be in hexadecimal.
Oh. Okay.
So any software, not any software, any brand you're using, let's say I'm using Siemens PLC, I want to use any brand, no problem. Okay. But if you want to control the inverters or something, any instruments lah, let's talk about instruments. Okay, any instruments. Okay. Then of course there will be a communication protocols.
Yes.
Okay, what type of communication you want to use, like Ethernet,
Yes.
like this serial, all that. Okay. Then once you decided what type of communication, then you need to know how to control the instrument. So when you go to the instrument manual, they will tell you, okay, if you want to control by PLC, okay, these are the values. All the values you see will be in hexadecimal.
Oh.
Most of the time.
Okay.
Because why? Hexadecimal is the older format of numbering in computers. Okay, but why? Because why hexadecimal? Because hexadecimal is they have 16 numbers.
Okay.
0 to 9, then A to F. Then only they will start 10.
Okay.
10 to 19, 1A to 1F.
Okay.
Okay. So what happened? If you want to store bigger numbers, you can use hexadecimal because they will use only less digits.
Okay.
Yeah, later I can show you. Okay, less digits. So that is the reason hexadecimal lah. Okay. Next, binary. Okay, we know binary is 0 or 1. It's a computer number lah. Okay. So whatever the number we key in our PLC, the number or value, everything, at the end, the value of course will convert become 0 or 1. Okay. So when we use 0, 1, I mean as a value lah. Of course lah, our program like digital input output is of course is a 0 1 only, correct or not? Okay. But when we will using like 0 1 0 0 1 0 something like the binary value are very rare also. Yes. Very rare. But if you want to understand some program, when you read the value, then you can understand okay which one is on, which one is off. Okay. Then the last one is the octal. Octal is used by PLCs.
Oh.
It's not. I think this one. I think last time we learned also. I think during our time we learned decimal, hexadecimal, and binary. I think octal very rare we learn. I think so. Okay. I also cannot remember. But of course, octal we don't learn. Because octal mostly used in PLC only, not in computers.
Oh. Yes.
Okay. Mostly used in PLCs, early PLCs lah. Okay. Why? Okay, why they use in PLC? Okay, have you heard about 16-bit,
Okay.
32-bit?
Yes.
Okay. So Siemens start with 8-bit.
Oh. Okay.
8-bit means 0 to 7.
Okay.
So that's why Siemens is using octal.
Okay.
Okay. Any PLC that is using starting with 8-bit, then 16, then 32, that PLC will be using octal. Okay. Like Omron all not using octal because they starting with they call 16-bit.
Okay.
They have 1 bit and straight away 16-bit.
Oh. Okay.
So that's why they don't need octal. They will be using the 16-bit. Okay. Same goes for like the Omron, Mitsubishi, all these some PLCs lah. Okay. So only Siemens, Schneider, okay. Mitsubishi also, some Mitsubishi model, because not all the models, some Mitsubishi model, Panasonic, Siemens, all these they using octal.
Oh.
Okay. Where they don't use octal as a value. Okay, like decimal, hexadecimal, binary, they will use as a value.
Yes.
Okay, means you can key like a pressure value, temperature value, some values. But octal they use in the address.
Oh, address.
Addressing. Okay, like you said, that's not the address, right?
Yes.
They will use addressing.
Oh, okay.
So means they will be using like byte by byte. Okay, 1 byte. Okay, inside that got 8 bits. We will have an octal. Okay.
Okay.
So later we see. Okay. Next. Yeah, this is one example lah. Okay. So hexadecimal 0 to 9 and A to F. Then decimal is 0 to 9 lah, right? Then continue lah. Okay. Then octal is 0 to 7, then 10 to 7.
Okay.
Then this is a binary number. We can convert. Okay. Enter. Actually, we can use our computer calculator to convert this.
Okay.
Okay.
Yes.
Right. So have you tried before?
Tried before for the binary data.
Oh yeah, we tried before. Okay.
Yeah.
Because sometimes some people they don't know this one.
Oh.
I think most of my participants they don't know this.
Oh.
They want if but they know they want to convert decimal binary. They convert using internet. They are not
Google.
Okay, they are not familiar with this one. Okay. But our computer is already built in, so we can use it. Okay. Next. Okay, this is the addressing. Okay, alright. You see, Siemens addressing is all the models. Just now we talk about a lot of models, right?
Yes.
All the models are same. Okay, I will tell you which one is different. Okay. So that's why Siemens is a bit famous because why they keep their the standard is from the previous until now the same type of addressing. All that because elaborately it's similar, but the older one and new one a bit there's a shift over on the addressing part.
Okay.
Omron also same.
Yes.
Mitsubishi also same. All now, all the PLC now is going to tag based. Tagging based programming.
Okay.
That's why the TI portal support tagging. But the thing is, TI portal have tag and also address.
Address. Okay.
Both have.
Oh.
Because address is their old style. Tagging is a new style lah. So what happened? They use both.
Okay.
Like Mitsubishi also have, but you can choose. If you want to choose using address only also can.
Okay.
Or address and tagging also can.
Okay.
And Omron also same. Omron now no address, only tagging.
Okay.
Only tagging. Availability also same, only tagging. So that's why. So when if you work with older availability or older Omron and now go to the new Omron, right? So much different.
Okay.
But in Siemens you won't feel that.
Okay.
Because that is the reason the older PLC also can what the 300 400 can be programmed using TI portal. Why? Because the Simatic manager they just modify this one. They use the same what is called the same concept. Then they implement the same concept in TI portal. So just the graphic will be different. The way we do programming, the most of the thing is still the same. Okay? Alright. Okay. Now you see, they use I for input.
Yes.
Very simple. Very simple. I for input. So they have byte numbers. Like I said, it's using octal, right?
Yeah.
Okay. So they follow the byte number. Okay. In one byte, I have 8 bits.
Yes.
Or we call it as a boolean. So I 0.0, 0.1, 0.2 until 0.7. Okay. So it means like let's say I have an input card. Okay. Let's say it's an 8 input card. Then it becomes I 0.0 until 0.7. Let's say it's a 16 input card. Then it becomes I 0.0 until 0.7. Then followed by 1.0 to 1.7. If 32 card, 32 input from here to here. Okay, something. So why? Because they use byte. Okay. Now the same input I can use as a boolean, a byte, word, and also double word. So it depends on the situation. Okay. So let's say it's a boolean, it's a digital input. Then I use this. If it is an analog input, because analog input is a value. Okay, you need to store values. Then I must use W. Why? Because inside here I have 16 bits.
Yes.
If the 16 bits are all 1, 1, 1, 1, 1, I will get some bigger values. If I am using only 8 bit, 1, 1, 1, 1, I will get 255 only.
Okay.
Which is small. Okay, so that's why all PLC same. All PLC for analog they're using 16 bits.
16 bits.
Okay. But now later on when we go on, then we can understand. Okay. Next. Okay. So any questions you have, just straight away can stop and ask me.
Okay.
No problem. Okay, because only one person only. So no need to worry. Okay. So output they use Q. Okay. In if sometime whatever, let's say I 0.0, Q 0.01. Sometime if the machine is built from in Germany, okay, and the wiring diagram is built in Germany, whatever. Sometimes the address will be E0.0, A0. Input they use E, output they use A. It's a German language.
Okay.
Sometimes very rare because last time, because we are not only doing trainings, we do projects, we do servicing, we do troubleshooting, we repair PLCs, we supply PLCs. All whatever is there in the automation, we do everything lah. Okay? But mainly training lah. The rest is because less manpower, so we do only small projects. Okay? But last time I do panel. The PLC panel, right? Okay. So because why? My boss partner, he has a company in Singapore.
Yes.
He told you right?
Yes, yes.
Okay, also whenever he do the project, any PLC project, okay, any old system upgrade the new system, okay, whatever he asks us to do the panel. Okay, the big panel, 2 meter big panel. So whatever he will give the drawing. So he have a team to do the drawing. The guys will create the drawing, then they will send to us. Then whatever check the drawing, then only I will buy the parts, everything, then assemble the panel, test, then only we can send. Okay. Now, so whatever sometime I have seen like this, the address in the wiring diagram. I just get confused. Why? Then when I check it before, then my boss said, no. AE means is output, A means is like. Because we don't do the programming, so I cannot compare, right?
Yes.
Because the program is done in Singapore. So we only do the panel, the wiring. Okay. Sometimes, most not all the time, sometimes. Okay? Okay? Alright. So the output also same concept. They have a big, byte, word and double word. Okay, thanks. And okay, memory. Okay. So memory is like we can call it as an internal relay. Okay, because you have I for input, Q for output, right? And memory. So memory is like, sometimes when you do program, you need to go to the next step. Because why they call it as the internal relay? Before PLC, they use all relay system. Correct.
Yes.
Okay.
Right.
Even some company, some system is using relay, right?
Yes.
Push button, relay on, then we have a timer on the relay. So what happened? PLC, they take out all the relay, all the system they put inside the PLC, make it a compact system. So that's why inside PLC, still the name they call this as a coil.
Yes.
The relay has coil, right?
Yeah,
Still the name is coil. This one is normally opened up.
Yes.
Now only the latest software they don't use the name coil. Now they changed the name to some other names like TI portal, no more coil. TI portal called assignment. Assignment means to assign some job there. Because the assignment not only this symbol, not only coil, they have some others you can change. So that's why. Because last time the Simatic manager only the coil only. So the name is still coil. The new one is the symbol is later on the symbol you can change to other functions. Okay. Right. So now, of course, you already take out all the physical relay, you replace PLC. Then you connect the input outputs, then you do program. When we do program, of course, some place we need to do some like, okay, when I start the lamp on, after the lamp, the timer want to off the motor. So how? Because if it is actual relay system means that we have a timer, timer will have an output, a contact, same thing. Then it's this one. Then that place we need to use the memory. Okay, that is number one. Number two, like HMI, we have a HMI, right? You press the button, see the value, all that using memory. Okay. Because why? I is the input, means it's the physical input from the machine to your PLC. I. Q is the output, so it's the physical output from the machine to the from the PLC to the machine. Okay. Then memory is inside the PLC. Next, DB also same is inside the PLC. Okay, DB also is inside the PLC. Memory and DB is the same thing. Memory and data block. Okay. Okay, what is the difference? In memory, they will give, okay, S300, okay, let's say this model, okay, they will tell you, okay, this model can use memory from memory byte 0 until 8000.
Okay.
Let's say they fix. Okay. But DB is not like that. DB is, they will give you DB. How many DB can use?
Oh, okay.
For example, this one can use 1000 DB. Let's say this PLC model can use 1000 DB. And 1 DB, inside 1 DB, you can use 8000 data.
Oh, okay.
It's like a block by block.
Okay.
So memory, like one set of memory they already give. Data block is they give multiple blocks. Then inside one block you can use so many data. Okay. So later on we will be using, then you can understand differentiate. Okay. That is number one. Number two is what is the difference? Both are memory type.
Yes.
Okay. The DB can keep value.
Oh.
The memory, if we have a program, we put some value inside the memory.
Yes.
Okay. Then the PLC you download new project. When you download new project, what happens? The old value inside the memory becomes 0.
Oh.
But the DB will keep the value.
Okay.
Unless you didn't touch the DB, then the DB will be the value will be there. Okay? Okay? There's a lot of things later we see on that one. Okay? Alright. Next. Okay. This one regarding your hardware. Okay. Okay. Here you have the CPU part number. Okay. This is actually the CPU model number. Okay, you can see right. It's the CPU 315 2PNDP.
Yes.
Okay. 2PNDP. Okay. 2 means I have 2 communication.
Oh. Okay.
PNDP means PN means is a Profinet.
Profinet. Okay.
That is the Ethernet cable.
Okay.
Here.
Okay.
The Ethernet cable. DP means is the MPI or Profibus. Is this port. We call it as a MPI Profibus. Okay. Here also you can see X1 MPI DP.
Okay.
And for this also you can see X2 is a PN LAN.
Oh.
Okay. So that is the part number. Okay. And on here we have BF1, BF2. Bus fault.
Okay.
Bus fault means it's a communication fault.
Okay.
Now it's blinking, right?
Yeah.
The one of the bus fault, right? Okay. You know why? Because that day I do some configuration. So I have a remote I/O connected to this.
Oh. Okay.
Now all the remote I/O removed.
I see.
That's why it's searching for the remote I/O.
Okay.
It's a fault. Okay. Okay. So now got 2. Okay. The first one is for this port.
Oh. Okay.
The second one is for this port. So
Oh.
anything connected to this, then suddenly is disconnected, it will show BF1.
Oh, only for the Profibus will show on BF1.
Yes.
Oh.
If anything I connect to through Profinet
Profinet.
and it's not connected,
Oh.
suddenly then it will show BF2.
Oh, okay.
Okay, because this one can network 2. One is Profibus, one is Profinet.
Okay.
Okay. One example. This one also same. So is one 315.
Okay.
2 PNDP, but you see only one bus port.
Oh, okay.
Okay, why? Because this one is what 2 port. You see down here, one is MPI, one is DP.
Yes, correct.
Okay. So DP is the Profibus.
GP is Profibus. Yes.
Only DP can do the networking.
Oh, okay.
MPI cannot do networking.
MPI can do.
MPI is for laptop to the PLC
Okay.
or connect to HMI.
Okay. Understand.
Only this one connect to a Profibus system. Let's say the Profibus system got error. Only will this one. It means this CPU only can network one connection. One combination lah. That is profit bus only. That's why only one fault.
Okay.
This one, because this board you can change MPL or DP. You can change.
Okay.
If I change to DP, it become profit bus. Then this one is profit net.
Okay.
So you can do two networking.
Okay.
So let's say I have one PLC, I have 5 motor using profit bus. Then all connected to here. You know profit bus cable, right?
Yes.
Purple color.
Yes.
Okay, later we do all this.
Okay.
Then so it will connect to the this port.
Okay,
the profit bus cable. So if one of the motor is problem disconnected, then I have BF1.
Okay.
Here I use Profinet. Let's say that I use Profinet, I have 5 motors. So say if one of the motor is not problem, not giving signal, then I will show BF2.
Okay.
That's the difference. Okay. So whenever you add this BF1, BF2, is it common in your place? No. Okay. If sometime like happen, then I will show you how to solve the issue. Okay. Alright. Then we have a LED status here. Okay. The first one is the system fault. SF1. Okay. SF is the system fault. Means if any fault happen, then the system fault will on. Very simple. Why now is the fault? Because it shows there's a communication fault. BF means it's communication, right?
Yes.
So there's a bus fault, that's why it's called the system fault. If this one is gone, this one will be gone. Yes. And also, if I remove the module, anything else, then it's a system fault. Then we have a DC 5 volt lamp, right? DC 5 volt. This DC 5 volt is for the memory card. Okay. Then we have force. Force means we in the PLC we can force some input outputs. Okay. So if someone force the input or outputs, then I can know here. Okay. Then of course run and stop. Okay. Then here you have the run stop switch, right? Run stop. MRES, right? It's a memory reset. It means if you press down, then if you need to hold up for data, I show you how to clear the memory. It means it will clear the memory values.
So if after clear, then we need to reload back.
Yes, not reload. It's not like there's a two-way. One is just normal. Normal just clear the value. The logic will be there. The program will be there. Just the value becomes 0. Okay. But there's another trick. You press on for a while. That one will be like erasing your program. Okay. But I will show you how to do that. Okay. Then what else? That's on the PLC lah. Okay. Then normally here itself you can see the version. Here. And normally here we have one cover. Right? But I take out the cover because my student they open sometimes break the cover. Very difficult. Okay. That's why the cover. So normally the part number will be on the cover or at the side.
Alright.
Part number. Okay. Then like this lah. You can see the part number. So Siemens PLC always start with 6ES7. Yes. Okay. Then this one is a Siemens power supply. But not necessarily must use Siemens power supply. Can use any power supply. No problem. Because it's just a 24 volt. That's all. So this one and this one is not connected. This one and this one is connected using this. This connected. Later on when you want to add something, you can add here. Okay. Right. Any question? Here.
So far, okay.
Next. Okay. Yeah. So the the main difference lah between these two, okay? Because Simatic Manager they are famous for this lah, right?
Yes.
The work memory, okay, the processor speed, then the number of communication lah, okay, the link I can do, okay. This one is low considered to this lah, okay, the number of Profibus connection, number of Ethernet connections, all that, okay. So it means since this one the I/O connection is more, of course the I/O is more on here, yes, okay. Then yeah, that's all. That's the main lah. Then another main thing is, like I said, this one can do redundancy. This one cannot do. So what they do when they release new hardware, so the 1500 can do redundancy.
Oh, okay.
The 1200 cannot do. Okay. Next.
But the programming language still the same.
Programming, everything is
the same.
Everything is same. Yes. Only the memory is bigger, so can do bigger program.
Okay.
Can control more I/O. That's all. That's the main difference. Okay. Then this one later we see lah. This one later, next. This one also later, next. Yeah, that's all. These two we later we see. Okay, others all we just hands on with the PLC. Okay. So for now, what we want to do, we want to try to back up the program first.
Okay.
Okay. You escape. Can minimize or close. Then you open Simatic. Yes.
Next.
Cancel. Because if you doing new project, then you can go next.
Oh.
Cancel it. Okay. Just close this bottom one.
This one.
Below one. This one, sir.
Oh.
Close. Other one. Open. Here. This X.
Oh, this one. Okay.
The below one. Yes. Alright. So whenever we open, it will be like this lah. Okay. Go to file. New. You put a name here.
Okay.
Let's say upload day 1 or backup. Okay, wait. Then go to browse. You save in your folder. Go all the way down.
Okay.
Okay, here. Okay. Yes. So whatever project you do, you save it here.
Okay.
Okay. In your folder. Okay. Now we want to back up. Okay. And make it bigger. Okay. You go to first. When you want to do a backup. Okay, now my laptop and PLC is using what?
The
MPI cable. Okay, it's not an MPI cable. It's considered like they call PC adapter.
PC adapter.
Yes. So in PC adapter, it means it can detect MPI, it can detect Profibus.
Oh, okay.
Both also. Okay.
Alright.
Because now we have only one port.
Yes.
Correct. That port is the MPI or DP.
Oh.
It's
Okay.
not like this one.
Yes.
That one is fixed, right? The first one is MPI, second one is DP.
Yes.
But this one we don't know.
Okay.
Okay. But from the fault we know, okay, it's configured Profibus.
Okay.
Because we know already there is a fault means it's configured. But let's say we don't know, right? So it's either MPI or Profibus. Okay. So you go to option, set PGPC interface. So we don't know. It's a PC adapter, right?
Yes.
You can select PC adapter here, auto. Then go to properties. Start network detection. try to check it. It shows the bout rate is 1.5 Mbps was detected. Okay, so it cannot determine what automatic. Okay, so we have to set manually. Okay, now I give you info. That is Profibus normally will be 1.5 Mbps. Okay. MPI 187.5 kbps. So if you see these two numbers, you will know which one is okay. Okay. So now it says auto cannot, right?
Yes.
So you click OK. So it asks you to select manually. And it shows the detected speed is 1.5. Okay. 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 Then go to choose Profibus. Yes. So PC adapter Profibus. Yes. Go to property. Okay. So it's a DP. Okay. 1.5. Okay.
So okay.
Yeah. Okay. So this one is just now is that they call set PGPC, yeah? Okay, interface. Now we already set PC adapter Profibus.
Yes.
Okay. Now go to PLC. Upload station to PG. Okay. View. This is the one. Yes. You open this. Alright. Click OK. Okay, done. Okay. You go to open this. Open some more. Okay, blocks. Go to blocks. So inside the block, okay, there's a few blocks lah inside. Okay. 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 First, okay, we go to the Simatic 300. We go to hardware. Yes. Okay. This is the hardware.
Okay.
You go to window. Arrange. No, go to view. Yeah, arrange. Auto arrange. Yeah. View auto arrange. Yes. Okay. So it shows that this PLC at the DP, right?
Yes.
I have a Profibus master system.
Okay.
So I have two Profibus connection.
Okay.
So that's why it's showing error because now the two connection is not there.
Okay. Okay.
Okay, so that is why the error. Okay, actually you can monitor. You click here online. Okay, auto arrange again. View auto arrange. Yes. You can see number 5 and number 4 is not detected by the PLC. Okay, good. Alright. Offline again. Offline. Okay. Can close. No, can close. No. Sorry. Wait. Close this one.
What's the sound?
No, the main.
The main
This
one.
is the close. Never mind. Close. But you already closed the Simatic menu.
Oh.
Open again. Never mind. So always remember, Simatic manager. They have a Simatic manager. Whatever you open, it become like new window.
Oh, okay.
So you can close all, but don't close the Simatic manager.
Oh,
But if you close also nothing. You can open back no problem. you see three blocks. Blocks. Okay. You know what is the program inside? Okay, never mind. You see FC1? Yeah, open. Okay, you see this is the one. Just now you asked me, right?
Yes.
No variable, no symbol. Yes. Because there are no parameter and local variable names. Okay? Okay? The open block does not contain any symbol. Okay. Yes. Nothing. No symbol. If no, they will have a name for this, right? Okay. Why? Why like this? Okay, you can close this. This
main one.
Main one. Okay. Yes. Why? Because when we download to the PLC, we only click blocks. You click here. You click this and can download. Okay. So inside these blocks, I only have all the blocks only.
Okay.
You click S7 program. Under the S7 program, I have, you see here, under the S7 program, I have the sources, right?
Yes.
I have the blocks, right?
Yes.
I have the symbol. But here you see don't have.
Yes, correct.
Because it's like an internally only. So what happened when we download, we only download the blocks.
Okay.
So the symbols will be in your laptop.
Okay.
It means in this file only you will have the symbol. When you transfer to the PLC, you are not transferring the symbol.
Okay.
That's it.
So if let's say means only the first programmer will know the comments.
Yes,
everything.
we'll have the comments.
If let's say like us, we need to troubleshoot, we can't.
Cannot. There's two things. One is you request the program from the maker.
Yes.
So he can give you like one example. If he give you, okay. If he is not giving, he say he cannot give you. Then what you can do is you do a backup.
Okay.
Then you open a symbol. Open the symbol. Okay. You already have your wiring diagram, right?
Yes.
You follow your wiring diagram. You key in your input-output address first.
Okay.
Of course, like in your PLC, it's not only input-output.
Yes.
You have input-output and so many of memory, so much of data block you will use. More than your input-output.
Yes.
This memory and data block will be more than your input-output. Okay, never mind. We do the input-output first. Okay. Then you save this block. You just give it a name, save. Of course, the name will go into the program.
Okay.
Now, after 1 month, you have a problem. Okay. This file you have the name one, right? You open this and go check what is the problem. Okay. When you troubleshoot, you see memory. Then you think, this memory is related to this motor. What is the function of the memory? The function of the memory to cut off the motor.
Okay.
So now you know the function of the memory.
Yes.
Now you can give the name for the memory.
Okay.
Slowly.
Slowly.
But you solve only this issue.
Yes.
Okay, you check. This memory. Then you see. Then when you check, then there's a memory is from your HMI.
Yeah. Understand.
Then you know already. This one is this
Okay.
memory. Okay. And you can give slowly.
Okay.
One by one, slowly. Of course, you cannot give all.
Yeah.
It's very hard. Even sometimes some people think, okay, never mind, I already have this. Then I go and study the program in full.
Yes.
Cannot study the program.
Understand.
Because one is the program is very long. Another one is because it's a logic, right? Okay. So we don't know how the programmer create the logic. Of course, they have the basic concept is there. Of course, one is start, then one interlocks, then output. That's all.
Yes.
But we don't know why they using everything.
Yes.
But when we have an issue, when we solve the issue, then we check, okay, this motor on, why not on, okay, it's the alarm, okay, what is the alarm, everything. From there, one by one, when we solve, okay, we can put name there.
Yes.
But want to study, cannot. Very difficult.
Very
You can close this.
This one.
Yeah, can. Okay. Go to File, New. New project.
New project is
No, new.
new.
Yeah. Okay, you give it a name. Day 1, Lesson 1.
K1.
Lesson 1. Okay. Browse.
My folder.
Yeah. Okay. Alright. So now it's empty, right? Just right click here. Insert new object. Okay, what do you want to insert? 300 station or 400 stations, Simatic S5, or you want to just add a communication first, or that's okay lah. Okay. So we want to add a Simatic, yes. Okay, you open this. No, that was okay. Just open this. Open Simatic there. Okay, you see just only that. You don't have the blocks, everything. Okay, because why? Because your hardware is empty.
Oh.
Okay, you open your hardware. So this one we call the hardware configuration.
Oh.
Okay, this one you pull a bit here.
Which one?
This one. This one you just pull this side. You can no. You click on the hardware catalog here.
Okay.
Okay, drag until the end.
Oh, yeah.
Until the end. I want to attach to the video. You bring up or until the end, go until the end. Sama. Okay.
Oh.
Okay. This one, you can make it bigger. You just drag this one. Okay. Yes. Okay. So go to 300, Simatic 300. Open. Okay. Rack 300. Yes, open. So rail. Rail is the rail lah. The middle one. Okay. Double click. Okay. This one you can make it bigger. Yes. Okay. Now, okay, the first one, must be power supply. The PS300. Yes. Okay. Now, first one is the first. Okay, this is the rack lah. The rail. Okay. So the first one is the power supply. The second one is the CPU. Third one is the communication module. Fourth one above can be any modules. Okay. Now, the power supply module is actually not necessary. Also, because why? Because like I said, the power supply and the PLC is not connected.
Yes.
Okay. Because sometimes we use external power supply, so we don't need to add. But for this, because it's there, right?
Yes.
In the hardware, so we add.
Oh.
Because why? Why we better to add here? Because if I don't add also can.
Okay.
Why it better to add here? Because let's say this one is spoiled.
Oh.
So the part number you don't know. Let's say the cover is broken or something. Then you can refer to here also.
Oh.
Okay. So that one I think is PS307. Yes, 5M. Yeah. Just select the first one. Okay, you select the second one. Select the first one. Load supply 120 to 230 VAC, 24 VDC, 5M. Okay. Second one. It's a 2M. 2M. Okay, so ours is a 5M. Yes, we take this here. Yes. So when you click, can you see automatically it's going to become green?
Yes.
So only can add in here.
Oh.
Okay, you double click also can. Yes.
Oh. Okay.
Now number 2 is the CPU. Scroll. CPU, yes. Yes. Okay, so yours is what? 315 315-2 PNDP. Yes, okay, open. Okay, got 3. Yes, can make it bigger. Okay, got 3 part number. Huh? So the one we have is the second one. Yes. Open plus. Okay. So how to know the second one? Okay, of course the part part number will be on the tower. Okay. Or at the side you can see that. Okay. So we have a project. We have doing this. So here you can see the contact numbers. 2EH30. Okay. Then the version here 2.6. Yes. Okay, wait. Okay. So it asks you to, if you whether you want to do any what Profinet or not. So no network, right?
Yes.
So no network. Just clear. Okay. So later, if you want to create network, you just can add. Okay. So this one I remove this now. Okay. Now, we add. This is the input card. I add one more card. We add 160 video card. Easy to do by hand. Okay. Okay, now you add. So number 3 is a special module, special communication module. So we cannot add.
Oh,
Already, okay. We go to number 4. It is your DI card. So DI cards, okay, you close the CPU. Yes, it's under the SM300. Yes. So DI 300. Okay. So ours is what? DI 32, right? No, sorry. DI 32 DC24. Okay, look for DI 32 DC24. Okay, got 2, right?
Yes.
The part number is here. The center one, 1BL00. You can see here. Yeah. Okay, this is the one, right?
Yeah.
Okay, open. Okay, so added number 4. Okay, and number 5 is the DO. So go for DO card. Is the DO 1624 DC.
16.
Ah. Also many. Okay. Here. So you check. Here also, okay. When you have cover, you can see the cover.
Okay.
Check the center one. Okay, fine.
Hold on.
1BH01. Go down.
Go down.
10. Okay.
0.
Yes. Okay, good. Okay. So actually, the number, right? Can you see SM322, right?
Yes.
Okay. If DI, the number is SM321.
Oh.
If DO is SM322. If DI, DO is SM323. The number from the number itself we can know it. Okay. So AI SM331, AQ is SM332, AI AQ is SM334 and SM335. If you need any spare, we have also.
Oh.
All refurbished on
Oh.
refurbished. But I have one set of PLC that is considered like it's used to consider used, but it's a scrap from the machine they using scrap right now. You know how old the machine? 2 years old.
Oh.
The machine is
Oh.
my cousin brother built.
Oh.
2 year machine because they already the companies the something problem. They have one system. They buy a new one, okay, and for 1 year they didn't use.
Oh. Okay.
Then the next year they use. Then they are closed down that process. Now no more using the process. So they close down. Yes. So this system they want to scrap.
Oh. Okay.
Then I tell my brother if they want to scrap, you check with the guy whether they can bring the PLC, just bring the PLC.
Yeah.
Then he brought out the PLC. The CPU, the power supply, same as this 315, but the EH14. Then DI card, analog card, DO card. Okay, good. Now go to station. Okay. Once we done all this, right?
Okay.
Consistency check. No error.
Check whether
Our configuration we do no error.
Okay.
Okay, of course this one of course won't be error.
Alright.
But when we do like networking, when we do profit bus, when we do profit net, then sometimes if we choose a wrong hardware, then it will show error.
Okay.
That is the most case. But like this a simple one normally won't be error.
So just need name, IC and email address. Yeah. Name according to full name. IC. Okay, this just now itself. I see. This one to prepare attendance and certificate. Email address. Yeah, so because I will at the end of the training, hard copy I will give it to you. Digital copy I will give it to you. Correct, huh?
Okay, no error. Then go to station, save and compile. Okay. When you save and compile, you minimize. Yeah. When you save and compile, then only you open this. I will get this. You open. Go to blocks. Yes, then only I will get all this. If you didn't save, I won't get this one.
Okay.
Because earlier when we add Simatic 300, I only have Simatic 300.
Yes.
because you don't know what hardware we're going to use. Once you choose the hardware, then you save compile, then only I will get all this. Because each hardware, because like you see the part number just now, right? There's 312, 313, 314 until 318. Okay? So all different type of models. Okay. Why different type? Because all different memory. So 313 have less memory. Memory, let's say there's 4,000 memory only. Like 312, 313. Okay. 314, 315, 316, maybe 8,000 memory. Then 317, 318, 319, 16,000 memory. Something like that. So depend then this 313, okay, how many Profibus can support? 315 different number of Profibus. All that you can get from the hardware manual. The number of memory, that one okay. Because in PLC you've got so many manuals. One is the hardware manual regarding your hardware. Okay. One is the user manual. User means okay, hardware, then how to use the hardware. Okay, they will tell you what software. Then there's another manual called programming manual. That manual is only for programming. So it will show how to do the programming, how to download, how to do the hardware configuration. So many manuals. Okay, good. Okay. Go back here. Go back to the hardware configuration. Here. Yes. Okay, once just now, so no consistency check done. Okay, save and compile done. Okay, now need to download. Yes. Okay. So your target module is here. Okay. Yeah. Okay, view. Yes. This one, this one. Okay. It cannot download. Sometimes got error. So otherwise, okay, let's do it. You know why? Okay, okay. Actually, it's already downloaded. Okay. Downloaded. Yes. But it said cannot reach. You know why? Okay, earlier the port line we are using the cable. Yes. Is earlier is port setting. It's a Profibus. Correct. Yes. Now it's a new project. Okay, you double click the MPI DB. Double click. Now it's the MPI setting. Okay, you close. I will tell you what happened. So you see, you click here. Yeah, it's a PC Profibus now. Okay, you see, your laptop to the PLC, you set Profibus. Yes. Because earlier it was Profibus. Now you create new project. Okay. New project is MPI. So when you download completely, now my laptop, my PLC become MPI. But my setting is Profibus, so that's why I cannot communicate. Okay. Okay. Now what you do? We go back to the option. No, not here. Go back to Simatic. Okay, go to option. Set VGPC interface. Okay, we check whether it's MPI or Profibus. Okay, go to auto. PC adapter auto. Okay, properties. Start menu. Yes. Can you see? Okay. So it's MPI. So that's why I cannot communicate. Okay, close. Click OK. Okay, now you can leave it auto or you can leave it MPI. Okay. But we can leave it auto lah, no problem. Click OK. Okay. Now go back to the hardware configuration. Okay. Now the PLC is run or what? Error. Nothing. Okay, stop. Okay. You put to stop and run. The the switch, ah, okay, run back. Can run? No error.
No error.
Okay. Now you try to online, we see whether I can communicate or not. Is it change to be stored in day one? Yes, okay. Okay. Can communicate early. Earlier cannot communicate. Earlier, what happened just now, when you try to download, when you download, right, what happened actually? The data will transfer to here. After download, my software try to run the PLC.
Okay.
But just now cannot run because of the communication problem.
Yes.
That's why we change, we manually run.
Okay.
Normally, when you download, after finish download, the software will ask you whether you want to run.
Okay.
Okay. Any question, teacher?
Okay.
So far, okay, yeah?
Yeah.
Enough? What's the type of we go for a break.
Okay.
On a coffee or tea we can make. Okay, if you are smoking, you can smoke it. Okay. Then after that we continue. Okay. the condo at the condo at the U-turn.
You tell
The flyover U-turn.
No, not 5-1.
It's
The one near
From the-
there's one car training school.
Oh, okay. The Sutra.
Sutra that side. Sutra that side.
Because last time I stay Taman Peling.
Oh, no, Peling. No.
I stay, you know the Chinese temple?
Chinese temple, yeah. Oh, there.
Behind the Chinese temple.
Oh,
And last time I stayed there.
I see.
How long you working in Singapore?
Very long already, since I was 26 years old. 10 years old. 10 years old, yeah.
Same field lah.
Same field. Okay, yeah.
Now you can minimize this one. Go to your program. So this one understand, right? But
Yeah.
I will, of course, I will do a few times.
Okay.
But later I will do. Okay. Now my style is okay, very simple. I teach you something, then I give you project.
Okay.
Teach you something, give you project.
Okay.
Because the thing is, you must be familiar with the software first. Software, hardware first. Because the programming, you can later on you can practice live or own. Okay.
Sure.
Then the main important is the what? You know how to download, how to upload, the addressing, the input output, address, the troubleshooting, then how to use a simple function like this timer, counter, everything. Okay. Now, so we do a simple project for this, simple program lah. Okay. Before that, okay, you see here the address. Alright. Okay, so we have a DI 32, right?
Yes.
DI 32 one. You can see down here. Okay, what is the I address? No, what is the I address? 0 to 3. Okay, what is the meaning? Okay, it means they start with byte 0 until byte 3. It's the byte number. Okay. So 32 means inside got 4 bytes.
Yes.
Because 1 byte got 8 bit.
Okay.
So it means I 0.0 until I 0.7, I 0 1.0 until I 1.7, I 2.0 until I 2.7, I 3.0 until I 3.7. Okay, so this is the byte 0, this is the byte 1, byte 2, byte 3. Okay, good. Okay. So this number are always the byte number. It cannot show the bit numbers. Okay. Always the byte number. Okay. Then for the output. For the output is what number? So it's a DO16, right? Okay, what number? 4 to 5. 4 and 5, right? Okay. But you see, actually, number 0 is not in use, correct or not, for output.
Yes.
Okay? Actually, we can change this number back to 0. Why this one is for automatic lah? Because later, for example later this one you want to change to output 32. Then the here becomes 0 to 3. That's why they are automatically formed. So once we arrange, we can change manually. Okay, you double click here. Addresses. Here. Here. Yes. Then system default. Yeah. Put to 0. Okay. Right. It becomes 0 and 1. Okay, why? Why 0 and 1 only? Because 16.
Okay.
Or 2 bytes only. Here 32. 4 bytes.
Okay.
So here means Q 0.0 until Q 0.7, Q 1.0 until Q 1.7. So this is QB0, this is QB1. Okay, good. Right. Any question? This one? Okay, yeah. Right. Now done. Okay. Now we do some changes, right?
Yes.
We need to download again. Okay. So go to station, save. Yeah, save or save and compile also can run, no problem. Okay. Online window. That's the online window. Okay, save again. Okay. Now download. Here. Yes. Okay. Okay, done? Okay. Now, done. Okay, you can close the configuration. You can close the configuration. Yes. Okay, go back to the Simatic. Okay, go to block K. By default, OV1 will be there.
Okay.
By default, because this is the main block, organization block. Okay, you open the organization block. Okay, give it a name, main. Then the language ladder. Okay. Alright. Can you see it's open here? Okay? Okay. You minimize this first. The main. No, minimize. Yeah. Go to S7 program. Go to symbols. Okay, so we add some symbols first. Let's say start, stop. Start. You add to be the next one. Next one, yeah. You put a name, start. Okay. Then the address you put I0.0. Yes. Because that's the first input, right?
Yes.
I0.0. Then stop. Okay, I0.1. Okay. Next one is the output motor for it.
Motor.
Motor. one output. This one change to Q0. Okay, save. Yeah. Okay. You can close. Yep. Go back to the ladder here, down here. OB1, down here, yes. Okay. You see, normally open, normally close, the output, the line, everything is here.
Yes.
Okay. Then the logic functions, the timer, counter, move, everything is here. Okay. Now you click here. We do a simple program. Okay, then it's normally open. Okay, then here you key in the address. Okay, you can key in both. You can key in the name, start, or the address I0.
Oh, okay.
Point. Enter. Okay. Or you can key in start. Also, okay? Okay. Give an output. You click here. Okay, then output. Yes. Put motor. Now type motor. Yeah, don't put I. Yeah. Okay. Enter. Enter. Okay. If you don't have name, then you must key in the address.
Okay.
If you already have the name, then you can key in the name.
Alright.
Okay. So when I start motor on, so let's say this is the push button. When I press motor on, when I release, motor off.
Okay.
So I want to hold, right? Holding. So I can click here, add a branch, normally open, then close the branch. Close the branch. Okay, click here. Okay, you can drag, can find here. Also can, or you can use this one also can. Okay. Here put the motor. Okay. And here, click here. Okay, normally goes. Yes. Good. Stop. Okay. Save. Okay. Now download this. Yes. Okay, OB1 is already exists because already inside got OB1 right. Okay, yes. Monitor.
That is online, right?
Yes. Here. No, sir. The spec. Yes. Alright. Okay. Now we don't have buttons. Okay. So for now, what we can do, go to PLC, display force value. Yes. Okay. This one you can bring to this side. Okay. You can pin this one. Yeah. So always on top. Okay. Then you can key in here the address for the start and stop. Then output lah. here, 1, enter, 2, right. Okay, then you can right click here, the first one, yes, right click, no, click on the side here, yes, force, yes, okay, so it means because we don't have any wiring yet, so we are forcing the input to on, okay, yes. Can you see? You have an output. Okay. Now you force off. What delete force? Okay. Means you delete force is a delete lah. Okay, never mind. Delete this one. Go to second one, make it true, 1. Can on off.
So what is the meaning of the dot? Something like this.
Where?
Let's say not the current is going there is green, then what about it? Dot?
Oh, there's no means there's no current flowing. That's all.
Oh, okay.
Okay. So because the ladder diagram is similar to like our wiring diagram, right? Okay. So it means like normally open. So so it's normally open, right? So when it's on, then it becomes closed. So current can flow, something like that. Okay. Okay. So the force function is if let's say we don't have the particular sensor with us. For now we want to temporarily run, we can use force. Or sometimes what you do, you just bypass the cable, right? Let's say one cable, not one sensor not working, just bypass, right? Okay. Or can use the force function. So can, okay. And if you're not using that time, normally we will be using during the commissioning time. You know, when you do some commission, of course the program is not there. Okay. So they will do some checking, is it the input output is correct, and we can use the force. Okay. Alright. Close. Okay. No need to save as a force. Okay. Yes, you can close. Then we stop here first. What we do some wiring first. Okay. Connect to some input outputs, some IOs. So easy. Yes. 5 lah. So you see if the cable is small, you can use the cable for the cable things. Okay. This one is output 0 to 5. Okay. This cable. This one will be this side. What I did here is this 2 is the power supply here. Okay. 24 volt. All these 3 connected, all these 3 connected. Okay. Then we have 6 inputs is out. Okay. 6 inputs is out. Okay. Then this is the input common. Input common means for the switches.
Oh, okay.
Because we need to give one common signal, right?
Okay.
So already at the back I'll give you. Alright. Common signal, right? So output also one common signal here. Okay. So that's why we can depend on our what we choose here. We need to connect that.
Okay.
Okay. Whether it's a positive or negative.
Alright.
Okay. And this is the 6 input, 6 outputs.
Okay.
Okay. Actually, this wiring there is any straightforward.
Okay.
Here itself they show you.
Oh, alright. Okay.
Okay. So this is the input.
Yeah.
For input. Okay. If you are using these inputs,
Okay.
you must connect number 20.
Oh,
Number
alright.
20 is the M.
Alright.
0.
Okay.
Then starting from number 2, number 1 is not using. Number 1, 21, 11, 31 is not using.
Oh, okay. So we just follow the number lah.
Number 2, yes.
Okay.
Starting number 2 is the they already tell you
Okay.
positive.
Okay.
So it means this is the loop cable, right?
Yes.
So this is the input common.
Alright.
Then you choose positive.
Okay.
Then this is the inputs.
Okay.
And for the output, it's the same thing, but you see, number 1 is the 24 volt.
Yes.
Number 10 is a 0.
Oh, okay.
Zero. Can you see they already give you?
Yes.
Okay, everything is here. Number 1 is the 24, number 0 is because only the output, number 1 and 11 all using.
Oh, okay.
For input not using.
Okay.
Okay, so you 24 and 0 volt. Starting from number 2 is the going to the lamp.
Oh, okay.
Okay, so you see here, going to the lamp. The lamp loop cable is what?
Oh, to the
0 volt.
to the
So this is the lamp loop cable.
Okay.
The lamp common. This one is the input loop cable, this is the lamp.
Okay.
So I think this one must go to the negative, this one must go to the positive.
Alright.
So for this, where I get 24 volt, you can take from here.
Oh, okay. Yeah.
You have 3 terminals.
Yes.
So you take just one of these, power up here, and this one you get 24 volt. Okay. And you get
Okay.
okay, okay.
Okay.
This one you can power up. So you use this cable, use this cable first. If you need cables, yeah.
Okay.
All I use refurbished cables. All I use my old cables and I do processing. all the inputs, all the 6 inputs, because later we want to do the projects easier.
Okay.
Good. Then only we connect lah. Now using only. Okay. Then the 0 volt. That's one. That's one. Then this 0 volt.
Oh, this 0 also need to.
Yeah.
Oh, okay.
Because for output, positive, negative both must have.
Oh, okay, okay.
Yes. One. You can just jump from here also can also.
Oh, is already have 0.
Yeah, already this one 0. This one 0, right?
This 0.
Yeah,
Oh,
you
okay.
can jump. You can use the small
Oh,
keyboard.
okay.
You jump also can. on only, but yes. Start, stop.
Oh,
That's why one output.
oh, okay.
But one output can see the line means all the output also can see.
Okay.
No problem. Okay, okay, good. Right. Okay, go open program. Okay, monitor.
Dia dah cari menu nasi.
Okay, good. Okay, okay, okay. Now, okay, go offline. Okay, sorry, what's it called? My online offline is this one lah.
Oh,
When monitor offline. Okay, you don't go to this online offline.
oh,
You don't even because the term I use
Uh-huh.
commonly use
Yeah.
I always forget the monitor. Okay,
okay.
so So online, offline means just like I want to see the program.
Okay.
Monitor all. Okay. That's all PLC. So when we do manual PLC, that's the problem. Okay, now.
One more thing.
Yes.
Just now you said online monitor and offline. It's using this spec.
Yeah, this one. Yeah, I don't need to use this one.
What about this one?
Same, but this one is just to connect the online partner.
Oh,
That's all.
Okay, understand.
So means okay, now it's not connected.
Okay.
So just connect only.
Oh.
Monitor means it will connect, then monitor, like together.
Okay, together. Okay.
That's why I always use this one enough.
Okay.
Good. Now, okay, continue. Let's do a simple program. Okay. So, if we want to add something,
Okay.
you right click network one, right click, insert network. Yes. Okay. So what we want to do, we want to add a timer. For example, okay, you click here.
Okay.
So timer is here. Okay. For so many timer. S pulse timer. S pulse means is the timer will start to count with one pulse in time.
Oh.
Okay. Then S packs so say ODT. Okay. So we going to use the ODT. Means it's an on delay timer. This is the common one. Okay. Why? Because I start, the timer will start to count.
Okay.
After the timer reach your set point, it will give you the output.
Oh, okay.
Then you can use that output to what? To control your system. Okay. So just double click this S. Okay. So this one here must have the timer output. I mean the timer address. Okay. So T0 here. Yes. Okay. This is the timer address. Okay. Now TV is the timer value. R is reset. S is the set. It means you energize the timer. Okay. Then Q is the output. So since this is an on delay timer, means when the input is on, I start to count. Once I reach my value, I give out. Okay. Then BI, BCD. This one is the what? The value. Value in integer, value in BCD. This one later we see what is that. Okay. For now, we only going to use the S, TV, and Q only. Okay. So at TV is the timer value. How many seconds you want? Okay. Have you seen before this timer? No. Okay. So you must put S5 hashtag. No, sorry. S5T. Yes, S5T hashtag. Okay, how many seconds you want? Let's say 10 seconds. 10S. Enter. Yes. Okay, why? Because S5 is because the S5 model.
Okay.
So this one, so they use the same format. The timer format, they use the same format.
Okay.
That's why the name is S5. Okay. Okay. Then here, this one must have input. Correct. Something to energize my timer. Okay. Who can energize? Okay. Let's say what I want to do is I start. The motor is on. Then after 10 seconds, the motor is off. For example, I want to do that. Okay. Now, when I start motor on, okay. At the same time, I want to start the counting also. Correct? Okay. So I can use the start button here, or the motor also can. Because both the start button and motor on at the same time. Okay. But for timer, the input must be always on. Then only can count. If you put the start button there, if I press, it will on. If I release, the timer will reset. So we use the motor here. Okay, put normally open motor. after done, I can use the T0 itself. Actually, I got two options. One is I can use the T0 to off the motor, or I can put an output and the Q, one memory here, like a one internal relay lah. Then I can use the memory also can. Both also can. Okay. But first we try the T0. First here. Okay. You put it here. Normally close T0. T0. Yes. Okay. Why normally close? Because when the timer is running, the T0 is off. After reach my set point, then only the T0 will energize. Then I want to cut off. Okay. So we do some changes to save first. Yeah. Actually, you can use this save also. Shortcut. Okay. Then download. Yes. Okay. Monitor. Now you will again start. See, timer running. Yes. Okay, good. Okay. Now you go offline. So I mean off monitor. Yes. Okay. Now what I want to do is, let's say I want to put a name for T0, right? Actually, I have two options. One is I go to the symbol, put the names, or I can right click here, just right click, edit symbols. Okay. For T0, yeah, I can put symbol name. Timer, put timer N1. Because motor one. Okay. Yes. And this motor one, I can change the name. You right click here, edit symbol, motor one, put motor one. Okay. What I want to do? I want to add motor 2. Okay, go to network, right click network 2, insert network. Okay, you put it here. So the T0, this T0, right, is the output of this timer, correct? Yes. So here I use normally close because I want to off the motor one. I can use here as a normally open. Click here, put normally open. T0. I want to use this to on motor number 2. Okay, motor 2 we haven't created in our table, right? Yes. Actually, you can create here itself. Click here. No, just click on. Add output first. Yes. Then you put Q0.1. Enter. Okay. Then right click. Edit symbols. Then Q0.1 is what? Motor 2. Yes. Okay. Alright. Okay. Then this one, do I need to latch? This one we call latching, right? Yes. Latching or holding, right? Yes. Here, do I need to latch or not? What do you think?
Only because of the off T0.
Okay, but what happens is, you see, I start motor on, then motor after the timer, T0 will energize, right? Okay, T0 on, here on, off. Motor can on already, right? Here also on.
Yes.
When this one on, your motor 1 will off.
Yes.
When motor 1 will off, timer will reset. When timer reset, T0 will off back.
Okay.
So, but sometimes we cannot, of course, this now only you are learning, right? Sometimes we see cannot imagine. So what you do, you just download and test. If it is work, if no need to latch, then no need to latch. If need to latch, then we need to latch. Okay, so that is the logic, no problem. The logic is need to practice. Okay. So you try to latch. One, you click here, click the line here. Okay, add the branch. Yes. Then normally open. Yeah, motor 2. Yes. Motor 2. Okay. Then want to use the stop button, you can use the same stop button here.
Oh.
Okay, copy paste. Yes, yes. Copy, Control C here. Okay. Done. Save, download, then you can test. Okay, now the green color, right?
Yeah.
Okay, if you want to see for all, you click network 1. Then only you can see all.
Oh, okay.
If you click network 2, you click network 2, it only show from the network 2.
Oh, okay.
Even inside network 2, you click the timer. If you show from the timer only,
Oh.
in front of the timer it won't show.
Oh,
I mean
okay.
the green color lah.
Green color. Oh,
So if you
okay.
want to see clearly, yes.
Ah.
This is the old software lah. Okay. Can you press that? Oh, you take out the T0 from here.
Yeah.
Okay, okay. Can. That's how you can play with the program. Okay, now it's like a continuous model. So in this case, you see, if let's say you want to run a program like this, in this case, I don't need this latch.
Oh, okay.
Correct?
Yes.
I don't need this latch. I don't need this stop.
Oh, okay.
Why? Because if I stop here, this motor will off, timer will reset.
Oh, okay.
And in this case, since this one and this one I don't need,
Yes.
this one directly I can put it here.
Oh, okay, okay.
Correct? Because you see, this line and this one is the same thing.
Yes.
Since our program is look like this, that's why we separate. If no, right,
Yes.
actually this motor too, right, I can put it here. This latching I can put it here. Stop, so I can put it here.
Oh,
And it become like more complicated.
yes, yes. Correct.
Not complicated, it's like become like so messy.
I see. Okay.
Okay?
Yeah.
That is programming. Okay. Now what I want to do, okay, you want to do something. I want you to try continue. Okay. That is make like a few motors running. Okay. So okay, let's say I have start, stop, stop button. Let's say we have motor 1, motor 2, motor 3. Okay. Then this one on for 10 seconds. When I start motor 1, this one 10 seconds lah. After this, this one. So after 10 seconds, this motor off, this motor on.
Okay.
Press F. Then after this motor on, this one motor run for 12 seconds. After that, no need to off this motor.
Oh,
Straight away on this motor.
okay.
Run for 10 seconds. This timer is up to you.
Okay.
Once motor this after 10 seconds, then both the motor off.
Oh, after that, more motor.
Ah.
Okay, okay.
Okay, can. Then I press start again. See, motor 1 on. After then motor 1 off, motor 2 on.
Okay.
Motor 2 run after 10 seconds. Okay, no need to off. Straight away motor 3. This 3 will on lah.
Okay.
Okay. Then after 10 seconds, both will off.
Okay.
Okay. Okay, try to do something. So you can be familiar. Okay.
But every time, let's say the timer, we every time need to use S5T.
Yes.
S5T, okay.
Yeah.
Okay.
S5T only. Okay. So because the format of the timer
Okay.
is they using the older format.
Oh. Okay.
Only in the TI portal is the new format.
Oh, yeah.
New format. TI portal. So this one all using older formats. That's why. The rest only for timer lah. You follow the S5. The rest is normal. Okay. Okay. Okay, we go for a break.
Okay.
Then after the break, we can continue lah.
Sure.
Okay.
Alright.
You going back home?
Just going back home far.
Okay, because the break is 1 hour, we can go.
Okay.
Continue lah.
Okay.
show me the Chinese shop.
Oh, is that?
Yeah.
Oh,
You're not familiar to this area?
not really. Yeah, very nice come to this Sutra.
This one, our so your hometown is not Johor?
No, one is at Kulit.
My father also from
Kedah. Oh.
Kulim. But he settled down in Perak.
Oh.
Okay. So just now the project, the program we have.
Okay.
Now we continue other functions. So mostly you do what for the S7-300? So you have machines S7-300?
Have.
What
But I seldom, I didn't touch on the PLC itself because normally I call supplier to help me. Because I don't have the software and the.
Yeah.
Yeah.
Okay. What is that? So your actually what your company do?
My company is actually sell CNC machine and then
You sell CNC machine.
and
Okay.
then servicing
Servicing the
repairing.
machine.
Yes.
Oh. Then the S7 is using what?
S7 is actually it's actually it's not CNC. Not
Okay.
the S7. It's actually it's a normal machine.
Okay.
Using S7-300 normal PLC.
Normal PLC. Okay.
Because the function is just we call it boring machine.
Oh, okay.
Just bore only. You
Okay.
don't need to so precise.
Okay.
So it's using this.
Oh, so just for
Yes.
machine using this lah.
Yes.
That particular machine is in your company. That one is not for selling.
It's actually doing servicing for other customer.
Oh, okay.
So a few of my customer, which is same your boring machine,
Okay.
using S7-300.
Or some is using the CNC.
Some is using CNC.
Oh.
If let's say retrofit, some customer they will change this Siemens 2.0.
Yeah.
They will change to Fana CNC.
Oh.
Ah.
Okay. Sorry. Okay. So okay, we continue with other functions. So you can close this. Close. Okay. Then you create new file. File new. Day 1 lesson 2. Okay. It's in your folder. Same like that, you add the PLC first. Right click. Okay, right click here also can. Here also can. That is not a problem. Okay. No. Insert new object.
Insert new object.
Yes. Simatic 300 station. Yes. Okay. You open the 300. Hardware. Then go to 300. First is the rack. Yeah. Okay. Then the power supply, CPU. Then you can add on the tags. Power supply first. PS 300. Yeah. then you change the address. Okay. Right. Go to station. Check consistency check. Okay. Then go to station again. Save and confirm. Then need to download lah. But actually no need to download because already downloaded in the so it's already there. Okay, we just continue with the program. Okay. At the same time, if you want the software, we also sell the software.
Oh, okay.
Simatic Manager.
Oh, okay.
Latest version is a Simatic Manager 5.7 Service Pack 2.
Oh, okay.
And if you want the license, then for your personal or for your company?
Oh, and do laptop personal.
For your self own practice lah.
Yes, yeah.
Okay, own practice data is part of it.
Okay.
But company one need license lah.
Oh, okay.
Because this one I will put my license.
Oh, okay, okay. Understand.
So this one is just for your self practice, self training or that. But if you need the license for your company to work on the machine everything, then you can contact us.
Okay, sure.
We also sell software.
Alright.
Okay. Can you close this? Now go to the Simatic 300. Open. You click on the S7 program. Symbols. Yes. Okay. So now what we do? We already learned. Just now we already see. Normally open, normally close. Quite simple, right?
Yes.
Then timer. So we will see what is set, reset, the pulse functions until here.
Okay.
Then we can do like a simple project.
Oh,
Okay. So want to learn the set reset. So what we do? We just put like a PB1, PB2, PB3. Push button.
oh,
Push button PB1. K1 enter. What is the address? I0.0. Enter. Okay. Can you see automatically become boolean?
yes.
Okay, because I0.0 is like 1 bit.
Oh,
So it's called boolean. Bool. Okay. Okay. Then PB2, PB3. Okay. Then for the selector switch, maybe you can put SS1, SS2, SS3.
SS.
SS. Selector switch 1. Yeah. SS2, SS3. For the output, you just put lamp 1, lamp 2 until lamp 6. Okay, good. Save. Okay. Close. Okay. Now, we go to blocks. Okay, OB1. One same main, naming as a main.
This one,
Yeah. Later also get the name, no problem. Okay. Okay. So OB1 means a organization block 1. Okay. Okay. For now we will be using this. Later on we can use the FC block, FD block, or that. Okay, good. Already open. The PB1, yeah. PB1. Okay. The output, I want to use the set. Okay. So it's under the big logic. Yes. Can you see S?
Yes, yes.
Yeah. You can just drag and put it. No. You can double click. If you want to drag and put, make sure put on the line. Okay, now here you put the line 1. Okay. No problem. Okay. Now, okay, what is this actually set? Okay. Okay. Let's say you know the symbol like S, set, like a timer, right? If you know the symbol, you can use this box also, or empty box. Yeah, later we try. Okay. So this one means is a without the S is a normal coil, right?
Yes.
This one we call set coil.
Set point.
Yeah, it means if you give one signal here, it will be like always on, always energized. So if you want to off this, you need to reset. Yes. So you add another network. Right click, new network. Yeah. Okay. So you click here. We open PB2. Then you can use the R. Okay. For R, I want to use the box. I'll show you. You click the box. So it will empty. But you need to know the code. So for S, for set is S. For reset is R, right? You just click R. Yes. You choose this R. Yes. If you know the keyword. Okay. Yeah. So this is also the LAN 1. Okay. Save, download. Then we can test. So can you see?
Okay.
Press.
Yeah.
Always on. Reset. Always on. Okay. It's similar to the one we latch it.
Okay.
Do the latching program. Okay. So this is a set reset. So your output, you want to use coil or set reset also can. It's depend on you.
Okay.
But the thing is that if you're using just a coil only, it's just only one line. If using set reset, you need 2 lines.
Nice.
Okay. Alright. Okay. Your CNC machine, who do the program?
CNC machine normally come
With the program.
maker.
Oh, for the maker lah. So you buy from the maker, then you go and assemble.
Yes.
Do the commissioning lah.
The whole machine is equipped with the CNC control.
Okay.
So normally we will assemble install all the machine.
Okay.
Do the commissioning.
Oh.
Yeah.
So if anything need to change,
We won't change anything.
no need to change.
Actually, we not encouraged to touch
Their program.
Just let's say like troubleshooting, like maybe sometimes when we do cutting, then the wiring will cut sometimes because of the chips.
Okay.
So the time we do troubleshooting based on the how to say I will log into a PLC, just see the one like you do the blinking.
Yeah. You go into the funnel
PLC.
PLC.
That side can display the ladder.
Ah.
Same thing, we have to see the book.
Yeah, of course. Okay. So Um, so the software how you use? You use
The CNC control, right?
okay in the screen.
When you press ladder, you have to go up the ladder. No need any software, no need any laptop.
Okay, in the I mean the screen
The
itself.
screen itself.
Okay. So you just press the ladder, show the ladder.
Yes.
Okay, then you just check lah which input
Yes.
output. Okay. Okay. So it means the program is already building.
Yes. Except for like sometimes the decoder, sometimes we need to add some arms or what. Every time we need to call supplier. Some supplier also free.
Okay.
Then maybe take 2 weeks time, but the thing is the machine is very urgent.
Mm.
Customer very urgent. We need maybe like another 3 days the machine need to run. That's why we need to commit the customer. Then I have no choice. Then come here to learn first.
It means the other system is using the Siemens one.
Yes.
Let's say you want to add something, yeah. You call the
The boss
someone
supplier.
to do lah. Okay.
But the boss not understand. Always push us.
Okay. So if you're doing any project or something, any troubleshooting, anything, if you want, if you need any consultation, you can call me. No problem.
Yes, sir.
You can WhatsApp me. You have my number, right?
Yes.
You can WhatsApp me. So just let's say any problem, just take picture and send to me.
Yes, sir.
Any error or something, need some consultation, so where to buy the parts or something like that. Okay, contact me. No problem.
Okay, sir.
Okay. Alright. Okay. Now, you go to monitor off. Okay. Click here. Number 2, you add one more. Yeah. It's a network. Okay. Now. Okay. We do one simple program. Use the normally open. Okay, you put the SS1. Okay. Then you put one output, lamp 2, normal output. Okay. Then I want to do a timer to reset it. Okay. You add one more line. Use normally open lamp 2. Okay. Then thing here. Timer. Put one timer. Okay, you can put this also. You put for timer is S. No, S underscore ODT. Yes, on delay timer. This is the timer one. Or you can take from the timer here also, right? Okay. So you put T0. Okay, then you put the S5 time. Ten seconds. Then S enter. So when this one on, lamp 2 on, this one only to dash right? Because it's a selector one. Then after the timer, I want to off the lamp 2. So you can put the T0 here, right? Normally close T0. Yes. on the SS1? Yeah, SS1. Yeah. Always on, right? And the timer is repeating, correct? Yes. Why?
The lighting side. No, because of the
Sensor, right?
yeah.
Go to level 3 and click on level 3. If because why, whatever, because after the timer, the T0, of course the timer will energize T0, right? Yes. Then I cut off here. When I cut off here, the lamp 2 will off. When lamp 2 off, timer will reset. When timer reset, this one become normally closed by. Then since this one is always on back. But with our normal eye, we cannot see that because it's very fast. Okay, why? First thing is because that's how the PLC works. PLC will scan the program from left to right and top to bottom. So this one scan, finish, go back. That's how it works. But the scanning is in milliseconds. So that is the problem. That's why we cannot see. If I put like one scanning like a 10-second timer, then I can see. Because after the timer cut off, then the PLC will go back here, scan this. When this one on, then only the output. But since this is scanning is very fast, we cannot see. Yes. So how to solve the issue now? There's two ways. One, I can use instead of using lamp 2, I can use these two cables. Then what happens? The SS will be like always on. Then when I cut off, I straight away can cut off this. But now, after the timer, I cut off the lamp, right? Yes. When the lamp off, timer reset. That is number one. Number two, I don't need the SS to be like always on. Okay. Physically, it's always on, yes. But here, I don't need like always on. Right. Okay. So what I can do? Okay. I can make it as a pulse. Okay. Go off mine. So the pulse, right, is here. Yes. P, you take out, put it here. Yes. Okay. So what happens? The P will scan this guy. P means like a positive pulse. N means it's negative pulse. It means when this line from 0 become 1, then here I just give one pulse. I supply only one pulse. I scan, I supply. I scan input, the output is just a pulse only. Okay. So for this, I need a memory. I need to put a memory here. Yes. So you put M0 for 0. So now what happened? This line from here to here is always on, right? But from here to here is just a pulse only. So what I need to do, of course I cannot use normal coil, correct? So I can change to set or I latch it. We latch and use the latching so you can understand better. You click here, you add one line. Okay, normally open. Yeah. Then this latching must join after here. Can. Okay. No, you click first. Okay, now you try. mouse here.
Bring the mouse. Oh, just bring the mouse.
Ah, yes.
Okay.
Then you add the lamp to him.
Yeah.
Yes. Then you can test. So you can see here, right, nothing, right?
Yes.
Okay, you off the SS. On again. Yes. But how this one on? Just one pass, but we cannot see this one, correct?
Yes.
So that is the why I asked you to latch it. Because this one just give the pulse only.
Okay.
So let's say when you do project or programming, when you see something like this, which is like these sensors are like always on, right? So we cannot, we cannot off the sensor because the sensor detect the object.
Yes.
But in the program, we can make it as a pulse.
Okay.
For example, let's say I have what is it? Like water bottle. Okay, it's just on the what conveyor. Okay, then I have a pump to fill it. Okay, so let's say this one is moving. Then once I detect, so there's a sensor to detect. Okay, then once the sensor detect, the bottle will stop. I mean the conveyor will stop. Okay, put it here. Then you need to start to fill. So let's assume the SS1 is the sensor. Your lamp 2 is the pump. Okay? So when sensor detect, the pump on. So pump is after 10 seconds, the pump need to off. So let's say you don't use the P there, what happens? The pump is continuously run only.
Yes.
So if I change to, because why? Because sensor always detect the my bottle. So if you want to, but I can manually go and off the sensor. But in the program, I can make the sensor as a pulse. And this is the way. But this one, the pulse, sometimes because when you do projects, okay, you in the flow chart they won't tell you this one need to pulse. This one need to use pulse. This one need to use what set reset. No. In the project or in the flow chart, they will just give you like when to on, when to off. What on, what off, that's all. When we do program, then only you know, okay, here I need to use pulse. This one I need pulse. This one I don't normally close. This one normally open. Okay? Okay. So we will learn, because here, we will learn how to do projects. Okay, at the same time, when you do projects, we will do troubleshooting as well. Because if your program is not working properly, yes, we learn troubleshooting. Then on last day, I have a company program. For example, I can use that to show you like a big program and how to solve the issue or like. Okay, because we need to learn. If you want to do something, because I know your idea is, I mean, to learn how to see the program, the hardware, upload, download. At the same time, the most important, you want to know how to troubleshoot. But if you don't know all these functions, how you will do troubleshoot? So that's why we will learn all these. Then learn. At the same time, we learn troubleshooting. Okay. Sure, okay? The parts you can understand, the set reset can understand.
Yes.
Okay. So what we do, we try to do one project. Okay, anything not clear, let me know. Because if you finish fast, then because I have my idea, okay, teach all this.
Yeah.
So if you are able to finish fast, you're very fast, you catch up everything, then we can learn other things also.
Oh.
Because we have 5 days. Okay, but this 5 days will be like compressed lah. Okay? Alright, now okay. What we do, this one you can just say, just no need to close, just say, okay? Okay. We do a project, right? Because your CNC, okay, I do one project like basic simple project or project, and later on maybe we can see what project, other projects. Because of course I think we will be doing like 3 to 4 projects here, but all small projects. Okay. 1 hour and 1.5 hour project. Okay. First, before that, I want to show you how we do projects. Okay. Whenever we do projects, first thing is we need the IO list, the input output. Okay, I just calculate the input output. Number 2 is the flowchart. From the flowchart only we can create a program. Okay, so I show you a simple flowchart. Okay. This flowchart name is the graph set, but that's method flowchart. Depend on the individual. Okay, how they want to do. For me, I prefer this because it's easy to understand. Okay, so you will have 2 symbols. One is the condition. Okay, and one is your function. What you want to do. Okay, so for example, condition means okay, what? Start button, press that button, press stop button, the sensor on. Okay. The function is what? Okay, when I press that, okay, what on? The motor on. Motor timer run for 10 seconds, something like that. Okay, so I do a simple one first. Let's say I press start. Let's say motor 1 on. Okay, then at the same time I want to run on a timer T0 10 seconds, right? Then after the timer motor 2 on. Okay, for example, like motor 2 on. That's all. Okay. Then let's see, I have one sensor. So I give you just now the one about the field pump. Nothing. So when I start, what I do, I put like a conveyor on. Okay, one conveyor is on. That's all. Then when sensor 1 is on, okay, the pump is on. Okay, pump is on. Pump run for 10 seconds. Then after 10 seconds, the pump off, then the conveyor on again. So this sensitivity, okay, here I need to add 1. First the conveyor off first, right? Then we need the pump on, right? Then after the timer, pump off, conveyor on back. Okay, so conveyor on back means my process go back to here. Okay, then if I press stop, like a emergency stop, for example, both the conveyor and the pump off. Okay, we try to do a program. So how? So first, start conveyor on working. That's all, right? But we know this is a push button.
Yes.
The conveyor must be continuously on until the sensor is on. So what you do, you can use the set of latching. But the latching they won't tell you here. Okay. Now, when sensor 1 on, okay, the conveyor need to stop, right?
Yes.
And the pump on. So it means the sensor 1 conveyor need to stop, then the pump on, right? Okay. Then just now we do lah. Then timer. So the pump is the timer. Let's say 10 seconds. Okay. After timer, the pump is so after the timer pump off. And at the same time after the timer conveyor need to on back. So it means on back means here right. But this program cannot work if you test. Why? First thing is, but this one need to imagine lah because we don't have anything. First thing is these two. Just now we discussed. Because this one is always on.
Yes.
Pump on after the timer it cut off, but timer continue back. So first we solve this issue. So we know that this one is a pulse, right? Okay. But here they don't give it. Then the memory 0.0. Okay. Then the pump. Now start conveyor on. Sensor 1 detect. This one give base catch after the pulse, right? Okay. Then the pump on. Okay. After the timer, the conveyor need to on back. But you see the timer, if I put like this, I cannot on back the conveyor because the sensor is still on what? The water is still there. So there's many way lah. There's one way is put like this. Also can, or let's say I want to use the sensor to cut off. I can use the pump to cut off. So when sensor detect, pump on. When the timer cut off this, at the same time can on back the conveyor. But this one all, so the first program I follow this. But later when the edit is depend on the machine, the program. So when you test, okay, you see, okay, this one cannot here change. Okay. Then when I stop, conveyor off, pump off. Okay. If I want to off the conveyor, stop. I want to off the pump. Okay, this is one example. Okay, now you want to take picture or take note? Take it first. Take it. Then we do one small project. So for that, what you do, your program, right, the current program, the Simatic manager, the ladder you close, the OB1 you close, then the Simatic manager you save as you can put day 1 project 1 or day 1 mixer project. Day 1 mixer. Browse your folder. Then you open OB1, you delete the program. Okay. You click on the network and control it. When you click on network, control it, then only you select all the network. Oh, yeah. Just right click, new network, save. So consider new project already. Okay, close, then your symbols. Symbols under S7 program. So symbols also later you can change. Okay? No need to delete, just change according to this. Okay. So I will do a mixer project. Okay. That one I always use as the first project because it's just a simple one. So you can be familiar with the software and everything. Okay. So let's say I have one tank, okay. Then I have a pump. Sorry, valve. Okay. Okay. Valve E. Let's say valve B. Okay. Then we have a pump. Then we have a mixer. Okay. Alright. Okay. So let's see. Normally tank we have what to do? Normally tank will have level switch. Okay. So it will measure the level, right? So it is an analog. Correct. It is an analog value because digital, you know the difference between digital and analog, right? Digital is just on off. Analog will have a value. Okay. So level meter normally will be an analog, but we haven't learned analog yet. So I just put like a limit switch, like a two floating switch. Okay. So one is the high level, one is the low level. Okay. Then we have start button and stop button. Okay. So we assume all the buttons, start, stop, low level, high level is all normally open button. Okay. So how it works? When I press start, the valve A will on, right? Okay. Valve A on. Okay. Let's say start to fill. Once you reach the low level, okay, now we don't have the actuator. Okay. So you manually on the low level, manually close. Oh, okay. Just imagine, okay, when I start, when valve A is on, just imagine, okay, the level increase. Then you use the switch on low level. Oh, okay. Then reach high level, okay, you on reach that. Okay. So the moment reach low level, I want to start the timer because I want to stop here. So this is 10 seconds. Okay. So this is for the chemical thing. Okay. Then after 10 seconds, valve B on. Okay, valve B on, valve B start to fill. This one for valve B until the high level. So for valve A, after low level, then only the time start. Okay. Okay, then from here to here, no timer. Just depend on the high level. Okay. Then once I reach the high level, valve B will off, mixer will on. Valve B off, mixer on. Yes. So mixer run for 10 seconds. Okay, 10 or 15 seconds lah timer. Okay. After the timer, after the mixer off, then the pump on. Pump will on. So when the pump on, the level will decrease. So first the high level, so you just imagine, okay, pump on ready. Then you off the high level. Then you wait for a few seconds, then off the low level. Then off the low level, completely the pump also off lah. We don't need to, we don't care about this. Make it simple first. Okay? Because if it is actual tank, then only because the pump we can stop here.
Yes.
We need to think about this also. But no problem. Okay? Okay. So this is the program. Okay? So first the I/O. Okay? So we have input. Start is I0.0, right? Okay. Then stop is I0.1. You have two push button. Yes. Then the low level, we cannot use the third push button. Okay. So we use the selector. So your selector is I0.3. Okay. Then the high level is the I0.4. Okay. So when you do this one, make sure you do this correct, follow the correct number. Output no problem because input we have two type of input lah. One is the push button, one is the like the selector. Output no problem, just valve A, valve A, B, then the mixer, then the pump. Okay? Now Q0, Q0, Q0.2, Q0.3. Okay? Now the flow chart. Okay, when I press start, I make it a simple flow chart first. Later on, once we done, then later on, if we want to add anything, can add that. Later on, I make it first. First is the first project. So valve A on first, okay, that's all finish. Then when low level switch is on, timer, okay, 10 seconds. Once the timer is done, valve A off, then valve B off. Okay, valve B don't have timer, valve B until the high level, right? So when high level switch is on, valve B off, mixer on. Okay, so valve B off, mixer on. Mixer on for 10 seconds. So T1, 10 seconds. When timer is 10 seconds, mixer will off, the pump on. Okay, so mixer off, pump on, so the level will decrease. So level decrease means first the high level off, then low level, right? When both the switch is off already, then only the pump off. Okay, that's all, finish. Then you press start again, then continue from here. Okay, so for stop button, I make it here. Stop. Valve B, mixer, DP, okay? All off, like a emergency stop. Okay, we make it something like this. Later on, maybe we can put like now for this, you just press, okay, everything stop. Later on, we can put like this. When I press stop, then it's like what? Continue, then next cycle only is something like that. Later on, we can modify. Okay? Okay? Do this first. If you want to do PLC program, very simple. Okay? Don't write all the program, then test. Difficult. Okay? when you test got problem, like you don't know why where is the problem is. The best way is, okay, when I start valve A on, right?
Yes.
Let's say for example, okay, valve A on. Then for valve A you can put the stop button, correct?
Correct.
Okay. Until here you test.
Oh.
Then continue. Okay, when low level on, timer run, valve A off, okay. Then continue from here. Then valve B on, when high level on, valve B off. Okay. Every time one output you do for on and off, you test.
Okay.
So easier. If it is not on or if it is not off, so you can check why. So you troubleshoot why you cannot. So if we solve here first, then here will be easier.
Okay.
Same thing. So mixer on, timer, after the timer mixer off. Then pump on, after the high level, low level, pump. Okay? Yeah. Try first. Any question you can ask me. Okay? Yes.
Okay, then off fill in until high level.
Okay.
High level. And when it reach high level, the mixer will on, off will cut off.
Okay.
And the mixer will on for 10 seconds. Then
So that the pump on.
on.
Okay. Now high level off. Okay. 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 Then low level off. Okay. Now what do you do? The PLC, right? I mean the PLC. You put to stop. I mean the PLC, the small fish. Stop. Okay, run back. Okay. Okay, now you start. Okay. Then low level on. Okay. Then valve B, right? Okay. High level on. Okay, mixer running, right? Okay, stop. Press stop. Okay. What happened? Go down. Stop. Because you put a stop here. Actually, if you ask me, this one no need here.
Okay.
You can use the T1 here. Right? Yeah, okay. Or another way, because here you put when the mixer is off, give the pulse, right? So actually you can use the normally open mixer and the N for negative pulse. Also can use.
Like opposite.
Yeah, opposite of this lah.
Okay.
Also can use. Or you can use T1 also can use. But there's many way lah. Okay.
Alright.
Now, now what to do? Okay. So I can minimize. I can minimize this one, the main. Okay. Go to blocks. Okay. Because the program is very long, right? So you can see. What you can do, you right click here, insert new object, variable table. Yes, VAT, okay. Just VAT, okay. Variable table is like a table where you can you can list down all the data you want to monitor. Okay. Open variable table. Okay. You key in here I 0.0. You right click the I 0.0. Insert range of variable. Starting from 0, what? You put 4. Okay. But number, the third one delete nothing, right? Third one can delete. Same for the outrows. Put Q 0.0. Okay, you right click. Insert range of variable. This one 3. Yes. But just now why 4? Because we skip one, right? That's why. Then you can pin this one. Monitor the spec. Yes. So you can see which one on, which one off. And actually this one is very helpful during your what? Troubleshooting. So you can just list down which input or output you want to monitor. Just list down here, then you can monitor and can see which one on, can see the value and everything. Okay, you go back to the ladder. Okay. No, I want that one. I want this. Yes. You move a bit. Okay. You click here, monitor. Okay, go all the way up. Okay, then you off both the low level, high level. Okay. Press start again. Okay, so you can see valve in here. So you don't need to see here also. Okay. Low level on. Okay. High level. So okay, you off the low level. Sorry, so you're supposed to off the high level first, right? Okay, we do it. You off the level, high level. You start again. Okay, then low level on. High level on. Okay, then high level off. Why you want to be on again? So like that. The third network. Okay. Why on again? Because the high level is off, right? But it's on again because of the high level off already, right? But it's on back because of the timer, right? Right. So the timer is not, is that so the timer will off when low level off. So but you cannot manually off the low level, correct? So but can I off the timer? Reset the timer, can off. This one. It means now valve B is on back because of the timer. Right. It's off, okay, of course, when high level on, off lah. But the moment high level off, valve B on back because of the timer. Okay, this timer is from where? From here.
Yes.
Why the timer is still on? Because of the low level. Of course, we can off the low level.
Yes.
But I can off the line here.
Oh.
Correct?
Yes, yes.
Okay. How to off the line?
The pause.
Okay. Pulse means then timer cannot run back.
Oh, yeah.
How? Okay, very simple. Okay. Why I need this timer? For what?
Like the time delay.
Yeah. Then what is the function of this timer now? When the timer on, what I do? I on the valve B and I off the valve A.
Yes.
Okay. So I can use the valve A here as an interlock. So when the valve A is off, the timer will reset.
Oh.
Yes. Okay. Let's say you put it here. But normally open lah. Yes. We will test then only we can understand. Okay, valve A. Okay. Then download. Monitor.
Press start first.
Start first, yes. See? Off already. But your valve B cannot on lah, right?
Yes.
Why? Because your timer is like on off. So you need to latch. The one. Earlier you didn't latch because the timer is always on. Now it's become like on off.
Yes.
So I need to latch.
Okay.
So you latch the valve P, then now you try again. I think you're on right. No, I think this one must be after the valve A. Because the moment timer on, your valve A is still in off state. That's right. after the valve A.
After the valve A on.
Low level off. Okay, click on this, then go on. Start. Okay, low level on. Because I think the valve is the problem. You remove the valve. Should not remove. Because since the timing scanning is very fast, so what happens is actually after this the timer will energize, right?
Oh, yes.
Here also will give the signal, here also will give the signal.
Yes.
Okay? But you see, here will on the signal will off the valve.
Yes.
So before this one, okay, some I do it, then you can understand. Because it looks like why, what is the issue, right?
Yes.
But it's actually problem. You see, I start valve A, valve A. Then low level valve A, timer, okay? Then here T0, VA, VB, you latch the VB here, okay? So this one normally goes to here, okay? Now, so we see how the signal work out. So this one normally close, can go through, this one normally close, right? When I start, what happen? Valve A on. Okay? Then the current will flow like this. Here is off.
Yes.
Then here on. Then when low level on, timer on.
Yes.
Okay? After the timer, what happens? The T0 will energize. What happens when T0 energize? Here cut off. Then here on. So the signal will go until here. Okay? Then what happens? So how the PLC work? Okay, PLC will scan this. Scan this, what happens? Okay, off. Off this one.
Right.
Then when this one off, here also become normally close. Here will not. Normally close. Here will off.
Yes.
Okay? Then what my PLC do? PLC will go here and scan this program. When scan this program, what happens? It check the timer, no signal, so it will reset the timer.
Oh, okay.
When reset, this one become normally closed, this one become normally open.
Oh.
Then my timer go here and want to scan, timer T0 already off.
Yes.
That's why we make it.
Oh. Okay.
So if I take out this, okay, so what happens? When I start, valve A on, timer on. After timer, T0 will activate.
Yes.
And T0. So here will activate. Okay, then here will cut off, right?
Yes.
So when scan, this one we can on the VB. Just now the VA is blocking.
Oh, okay.
So it will cut off, then scan. Next scanning only it will see VA is off. Then only it will send. Okay, try this. Sure can go. cannot, then you have to use another way. Okay. Still cannot. What we do? Because the same problem, the timer very fast. So what we do? We don't use T0. Okay. What we do? We create a memory. So M0.0. So here M0.0. Oh, just now you already used the pulse somewhere, right?
Yeah.
So maybe M0.1.
Oh, 0.1 as well. I use.
Oh, then 0.1. Whichever is free, right? So now what is in this case? The same thing. So after this one, running, after the 10 seconds, it will energize this. Then what happened? This one will on here. So PLC will go here first. Energize this first. Then this one will cut off, right?
Yes.
Then PLC go here and check. Okay, it's cut off already. Off. Okay, and off this one. Then PLC come here and scan. Oh, this one off already. So I off. Timer preset. So this T0, this Q here and here got a small delay.
Oh.
That's why this one able to run. Try this. That's why timer normally, if you are not using like this, if you are just using timer, then only cut off this. Then T0 will use. If you are using like T0 on, we cut off the same T0. If you want to on something, then better to use like this. I mean the memory. Then change M0.2. Okay. Then also M0.2. Okay. So if right click here, rename, right click, edit signal. You can M02 is put VA off, VB on. VA off, VB on. VA off, VB on. So easy to understand. Okay, download that. Now can go. Okay, 1B on. HL off. Yes. See, VB not on again. Just now VB on again, right? Just now.
Yeah.
Yeah. Okay, why? Because now I'm using the memory because the timer already reset. Earlier that we don't have this, so timer is still on. So after the high level off, VB on again. Now off the low level. Okay. Now, for example, let's say you on low level only. Anything happen? Nothing, right? Okay. You off on high level only? Okay? Mix up. Okay? Why? Because you see, for low level there's an interlock, right?
Yes.
For high level there's no interlock. So what we can do here? Okay, so also we can modify. You see, my idea is okay. You can put the valve B here as an interlock, but you must remove this. Why? Because the moment high level on, the valve B is still on, I on the mixer. Then I can use the mixer to cut off. Okay, I will tell you one. So same thing. Okay, but this one, that's how the PLC works, the timing of the PLC, and that's how it works. You see, why I say need to change. Here, you see, M0.2 HL VB, right? VB. Then when HL on, I can put the VB here. This one the pulse is okay. Then so if you put VB, there no need to pulse it. Mixer. Yes. Inside. Why I ask you to remove this? The moment VB on, so normally close, right?
Yes.
VB on. Okay. Then VB on here. The moment high level on, right?
Yes.
Here also on.
Oh, okay.
So what happens? It will cut off the VB. So this one will off. So I cannot on the mixer. If I remove this, I put mixer. So it means so initially mixer is off. So high level is on, VB is still on. I give pulse to the mixer. So let the mixer on first. Then I use the mixer to off. So when the mixer on, here off. Good idea? So you see, actually high level and the mixer is on at the same time.
Yes.
Right.
Yes. Right.
But you see the small timing there.
Okay.
Because high level can on first.
Yes.
But when the PLC comes scan here, then only the mixer on.
Okay.
So there's a small thing. That's why. Can put this.
probably difficult to swallow.
That one okay. This one is logic. Logic, no problem. Okay, because you done until here just now. It's already good enough. Because normally this project normally I will do on the second day only. But I see today you very fast. You understand the set the function. So okay. My most important thing is you able to understand how to use the software. One. Okay. The addressing. Okay. The data types. You just check all these. Okay. Data type boolean. All that. That is important. Okay. Alright. Go for a break. And after the break, we continue. Maybe we can try. You can try to do this project using set preset. Another way.
Alright.
Coffee or tea? modify this file and make into set or you can take new files okay. Maybe
Let's see this one.
yeah, okay. You can save this, then you can close this. Then what you do, save this also. Go to file, save as V2, mixer version 2. Yeah. Yes. Okay.
Something right. Another version.
Yeah, another version ready. Then you go to the blocks. Go to Omron. And you can remove her. Remove what you want to modify.
sorry.
You can use the timer.
So on for 10 seconds.
Yes, okay.
Then
You don't confuse with this one. Because you see, this is the condition.
yes.
This two is the function.
Okay.
It means the pump on, not because of the mixer off.
Oh.
The pump on is because of the timer.
Pump on because of oh.
Everything can be.
That one you check already.
No, I haven't messaged him.
The HMI.
Yeah, I haven't messaged him yet. Because I don't know what is the
What is the program? He said program that particular HMI.
Yeah, I need to know how
Because in that machine, they said that machine have one HMI already, but no program inside. They want to program it. They just recently commissioning it, but they're looking for a programmer to program it. And if you can, there's another machine also, but doesn't have HMI.
check
Which one
what
of the
PLC, what PLC model.
yeah. Then I'll just inform him that my engineer will contact. Because he wanted at least a rough price by today. So I said, need to know the details first.
Yeah.
time lah. Today they want me.
put stop here, right? It won't work actually. Yeah, for this. This one okay. Go down. Set this. Right. So you go up. This stop okay, you go up. This stop it won't work. Because you see, I stop right, nothing.
Okay.
So
What's the reset?
yeah. Okay, you go up. Okay, go offline. We modify it a bit. Okay. Actually, this one right, you can add here also. No, you click here, the queue. You add a branch. Yes, then the set you can put it here. You just drag. Yes. You just drag. Click on the just drag. Or click on the S. No, click on the S. Drag. Okay, right. Okay, never mind. Just copy paste. Drag paste. You copy the S. Okay. Yes. So network 3 no region. Yes. Okay, to this one is stop here.
This
No need, right? Go down. It's a stop, okay. So for other stop, right? For valve A, valve B, you see, you don't have stop, right?
yes.
Okay, what you can do, you go down, all the way down. You add one more network. Okay, you put normally open stop button. Okay, then you reset all.
Reset.
Yes, reset all the. Actually, you can copy paste. Just copy, paste here. You add a branch. You add 2 branch. Okay, you copy this. Okay. No, just paste. It will automatically go over there. Okay. Then another one is the this is yes. Okay, save. Now you stop. Okay, but you see that's why the set we have so many lines.
Yeah.
It looks like easy, but so many lines. But if you using the coil, only one line.
Yes.
Okay. So how you feel today?
Very good.
Very good. Because I know today I make you to play with the software.
Yes.
Okay.
Correct.
And tomorrow onwards, then we will more concentrate on data types because in PLC, because this is the logic. Logic is strong, no problem.
Okay.
The most important thing is you know how to software, and most important is data types. So far, we only do Boolean.
Yes.
And tomorrow we do integer, double integer, and so on, the HMI, and one by one. I think you can learn a lot of things because you can very fast. You can grab the chart, so you can learn a lot of things. Okay. Right. Now then you can just save whatever you do and close. Then you can continue.
So for this one, I can save inside the thumb drive and then just type if let's say we install my data as
Yeah, of course, of course.
Oh, okay.
That's why I asked you to put in a folder.
Folder
On the last day, you can copy the file.
Oh, okay, okay.
Then your Windows, your desktop Windows, what Windows?
Windows 11.
Windows 11
Yeah.
home. Okay. Can. Then the new version can.
But if let's say like let's say I want to use in our machine, right? Oh, I need to apply another one. I need to buy another one.
Yeah, because normally what happens is okay, because in your laptop I am installing my license.
Yeah, okay.
So if you go and if you can use your laptop, go and do troubleshooting.
Yeah.
If anything happen, then they will check your
Oh.
software where you buy the license or something.
Understand.
So they will do like they will like they will blame that the software make this problem or something like that. So that's why better to have a license. So if anything happen, you can tell them it's not because of the software, because the software is original license. That's why all our laptop here we put the original license. I mean this training one, this one is for training.
Okay.
But the original one we keep. So this laptop I install all the original license.
Okay.
So whenever I go for troubleshooting or programming projects, I use only this laptop.
Oh.
I don't use other.
Okay.
So if anything they ask, because these machine makers not machine makers the company if something problem right, then you tell them this is not a PLC issue, this is some other issue, right?
Yes.
They will tell you, oh no, this is the PLC issue.
Oh. Okay.
Because the engineers they cannot solve the wiring. I mean the other parts, mechanical parts, they always blame the PLC. Actually, a PLC won't give you any issue.
Yeah,
Because
understand.
the program is already there. Like you
Yeah.
said lah, maybe one of the output is burned.
Yes.
So need to change one.
Correct.
That's why better to have the original license. For yourself batteries, no problem. I can install our license.
Okay.
Because I can install with the simulation.
Yes.
So without the PLC also you can get batteries or something.
Is it expensive if let's say I install the
original
one?
if not mistaken, the professional version for only Simatic and the latest one. Because that day I sell, I think it's around 11,000 something.
Oh, 11,000. Wow.
Very expensive. Very expensive. Siemens one expensive.
Yeah.
Siemens one, the TI portal
Yes.
TI portal only for PLC software is around 12,000 plus.
Oh.
Okay, the TI portal, PLC and then HMI together
Okay.
is around 16 to 18,000.
Okay.
So depend on you buy one software for what you want to use.
I see.
So TI portal also have basic.
Oh.
It's around 3,000 to 4,000 only.
I see.
But only can use for this model.
For this model.
Only one model can use.
Okay. I see. But if let's say for troubleshooting purpose, I still can use the normal.
Yeah.
Just don't edit anything.
There's no anything.
Okay.
Yeah.
Understand.
Because sometimes the company they want to see if you are using Simatic Manager.
Yeah.
Where is the license? That's the problem with company.
Okay. Understand.
That's the thing. Like Microsoft Office.
Yes.
Office or something like you see some company laptop, you can install the normal version, must have the original.
Yes. Oh.
That is the thing, right? No means any software can use.
Right.
Because they strict on this. And nowadays, what happens? The now latest software,
Yeah.
you install, then after that Windows update, the Windows security update, you go and disturb the software.
Oh.
That day happened. My TI portal, I installed version 18 for training. Because normally, like one day before, I will set up for training.
Yes.
Come and set up, checking, can open suddenly. All my laptops. Then I check, I see one of the Windows update, security update, go and clash with my software.
Oh. Okay.
Go and uninstall the update, then only can.
Oh.
Some of the software like LM very expensive. LM software how much? 34,000.
So expensive.
But it's a professional version. There's so many versions of professional. And the standard version I think is around 24,000.
Oh.
LM
No wonder all the supplier got very expensive because of the software.
Because of the software.
I see.
This is just a small job only, just want to change.
Yeah.
But they already invested their money in the software.
Yes.
Right. So how they want to take back the money, right? That's the thing. For here, sometimes I go to troubleshoot.
Yeah.
I only charge like 800 only.
Mm.
That one also they try to pay.
Oh.
They will say, oh, you got 800 or say, but if I tell about this, they won't know. Yeah, of course you can go to can go and troubleshoot many companies. Right. But you see, if I 800, right, if I troubleshoot around 12 companies, then only I can get back the money.
Yes, yes.
Then only the rest of the money only is like my money.
Understand?
Yeah, for transport or everything. Sometimes they don't want to
You
listen.
understand?
Yeah, they don't understand about the software,
Oh.
software, the laptop.
Yes.
We invest, we buy the software, everything, right?
Correct.
You know how much the Siemens software? Any Siemens have their laptop, you know?
Oh.
Yeah,
Oh.
they have their laptop. If you buy Siemens laptop, the latest one with the software, like with the TIA portal full version, okay. Yeah, I think they come with, but you can select. But if you buy TIA portal full version, Simatic Major full version, okay, and a laptop, 75,000. But the software, if you can't only the software only, it's around 40,000 plus. The laptop itself, is, I think, is more than 20k. Very expensive. Normal Windows only.
Yeah.
But Windows Professional.
Oh, okay.
That's the thing. Windows Professional. The body is, the industrial type.
Yes.
Then RAM 64 GB quality RAM.
Okay.
Then quality RAM.
Okay.
Then SSD. 2 SSD. 1 terabyte, 1 terabyte. SSD. 2 SSD. 1 terabyte, 1 terabyte.
Oh.
Then actually I think if not mistaken, 4 slot of RAM.
Oh, okay.
They only use 2.
Oh,
Another
okay.
2. So this 2 itself is already 64. There's available element.
Understand.
So that's why very expensive.
Okay.
Automation is very expensive.
Very expensive.
Sometimes. Because recently we do a project for PTM. PTM, right?
Yes.
The lecturers are doing some research.
Okay.
So they need to build a machine to do the research.
For me, right?
Yeah, it's fine. So they build a machine for do the research. So they asked me to build a control system, PLC and HMI. Okay. Then they asked me to buy the sensors and supply. But I didn't. I asked another guy to come and install. I only buy. I just buy only the CO2 sensor.
Oh.
It's very small. These people.
Huh.
I buy. It's around how much? 1,200. 1,700.
Very expensive.
Only the sensor. Very expensive. Go and install the panel, everything. Then Saturday, Sunday I need to